You are a security engineer at Buy for Sure Inc., a thriving retail store eagerly promoting its latest jewelry brands. The company is counting on your expertise to strengthen the organization's security posture and safeguard against potential threats during this crucial sales period. Do you remember all you have learned about securing access, identity protection, platform protection, application and data security, network security, and managing security operations? This course will help you recall all the key concepts you have learned thus far to contribute to Buy for Sure Inc.'s success. Hello, and welcome to Capstone and Practice Exam, the 7th and final course in the Microsoft Azure Security Engineer Associate Professional Certificate Training Program. I am Ramanujam Srinivasan, and I've been a technologist for the past 25 years. I'm a certified cloud and security architect and help Fortune 500 companies formulate strategies and implement security solutions. I'll be guiding you through this course. We have organized the course content into 3 weeks. In the first week, you will reinforce your mastery of the 6 courses you have completed. In the second week, you will apply the skills acquired in a Capstone project. Finally, in the third week, you'll put your AZ-500 knowledge to the test in a program-level graded practice exam. Now let's delve into the details of each week's content. In week 1, you'll revisit the core concepts covered in the 6 courses you have completed. In the recap of Course 1, Secure Access with Azure Active Directory, you'll refresh your knowledge of the licenses, terminologies, and features used in the Azure Active Directory, frequently referred to as Azure AD. Then you'll review creating and managing users and groups in Azure AD. You'll also recall how to manage secure access by authenticating and authorizing users and applications. Finally, you'll revisit the authentication options available for the hybrid identities. In the recap of Course 2, Identity Protection and Governance, you'll strengthen your understanding of protecting identities in Azure AD using conditional access, multifactor authentication, access reviews, and other capabilities. You'll also refresh your understanding of planning and configuring privilege identity management, or PIM, for roles and resources. You'll brush up on designing an enterprise governance strategy and managing resources using role-based access control, or RBAC. You'll also revisit deploying resource logs and Azure Blueprints to manage and secure resources. In the recap of Course 3, Implement Platform Protection, you will reacquaint yourself with the perimeter-level security strategies Azure provides to help prevent attacks on your Azure solutions and the deployment and configuration of network security groups. You'll also reinforce your knowledge of implementing application security, configuring and managing host and container security, and managing access to Azure Kubernetes Service, or AKS. In the recap of Course 4, Secure Your Applications, you'll refresh your knowledge of configuring and managing Azure Key Vault and securing applications in the Microsoft Identity Platform. You will revisit Azure AD authentication scenarios for different applications. You'll also look at configuring Microsoft Graph permissions, managed identities, and web app certificates. In the recap of Course 5, Secure Your Data at Rest, you'll refresh your knowledge of securing Azure Storage for access control and configuring authentication and encryption for storage accounts. You'll also revisit concepts related to configuring database security and monitoring, enabling Microsoft Defender for Cloud for structured query language, or SQL databases, and implementing data masking and encryption. In the recap of Course 6, Manage Security Operations, you will go over the key concepts of configuring diagnostic logging in Azure Monitor and configuring Microsoft Defender for cloud security policies. You'll also look at enabling just-in-time virtual machine access, or JIT VM access, and creating custom analytics rules in Microsoft Sentinel to strengthen your cloud environment's security. Finally, you'll revisit investigating incidents and threats with Microsoft Sentinel. In week 2, you'll engage in a captivating Capstone project, which will provide hands-on experience to prepare for the AZ-500 exam. You'll be presented with a real-life project scenario and guidelines on how to complete the project. On completion of the project, you will upload your submission for peer evaluation. You will then peer review the submissions assigned to you. After submitting your project and reviewing the submissions assigned to you, you will go through a project solution document. You may then discuss the key project takeaways with your peers. In week 3, you'll have the opportunity to put all your learning to the test by attempting the practice exam. You'll be presented with an introduction to the practice exam and the AZ-500 exam. You'll also be presented with an exam study guide to help you prepare for the AZ-500 exam. The practice exam, lasting 120 minutes, will consist of 40 questions in a format similar to AZ-500 exam. Finally, you will go through the steps for enrolling in the AZ-500 exam, followed by a discussion prompt where you can discuss key insights with peers. That was indeed a wonderful learning experience. Wishing you success in the practice exam and the AZ-500 exam.
Hello, and welcome to the recap of Course 1, Secure Access with Azure Active Directory. In this video, Introduction to Azure Active Directory, Licenses, Terminologies, and Features, you will recall that Azure Active Directory, also known as Azure AD, is a comprehensive identity and access management solution from Microsoft, crucial for organizations seeking efficient user management and authentication across their cloud services and applications. You will also refresh your knowledge about the different Azure AD licenses and terminology. You'll explore the Azure AD features that streamline user provisioning, security, and application access, making it a versatile tool for businesses of all sizes. Investigating the roles available in Azure AD helps organizations assign appropriate responsibilities to users and maintain security best practices. Creating an Azure AD tenant is essential, providing a centralized hub for managing users and resources. Additionally, deploying Azure AD domain services extends on-premises Active Directory functionalities into the cloud. Embracing Azure AD enables seamless access to Microsoft 365, Azure services, and various SaaS applications, fostering a secure and productive environment for users within the organization. Azure Active Directory, or Azure AD, is a cloud-based identity and access management service, enabling users to access external and internal resources. How will you begin using Azure AD? You'll first create a tenant in Azure AD. The tenant represents your company. You can create user accounts in the tenant. Now that you understand Azure AD, do you think it's the same as Active Directory? Though Active Directory and Azure AD share a similar name, they are separate services used for different purposes. Azure AD is a cloud-based identity solution that helps you manage users and applications. It's used for internet-based services and third-party SaaS applications. Active Directory manages objects such as devices and users on your on-premises network. You use it for authentication and authorization for on-premises printers, applications, file services, etc. The authentication method used and the structure differ between Active Directory and Azure AD. The service you use depends on your organization's needs. You can use Azure AD and Active Directory together to provide users with a single user identity called hybrid identity. Users can use the hybrid identity to access applications and resources on the cloud and on-premises. Azure AD has several licensing options. These options include the Azure Active Directory Free, Pay-as-you-go, Microsoft 365 Apps, Azure Active Directory Premium P1, and Azure Active Directory Premium P2 licenses. You can view your active license plan and try or buy licenses in Azure AD. Now let's quickly look at some of the frequently used terminologies in Azure AD. Account, Azure AD Account, Azure AD Directory, Azure Subscription, Custom Domain, Global Administrator, Identity, Multi-tenant, and Owner Role. Let's review some of the most exciting features of Azure AD. You can use Azure AD as a cloud-based solution to manage user access for all these apps, such as Microsoft 365, the Azure Portal, and thousands of other software as a service or SaaS applications. It can also help your employees access internal resources such as apps on the corporate intranet and any cloud apps developed for the organization. You can use conditional access policies to require users to pass additional authentication challenges before they access an app. Azure AD helps you generate reports covering sign-in dates, user details, apps the user has used, risk detection, and location through the Azure Portal or specific APIs for programmatic usage. Azure AD also has an identity protection feature called Azure AD Identity Protection. It uses risk policies to detect and respond to threats automatically. Azure AD can also be integrated with an existing Windows Server Active Directory. This allows your organization to leverage existing on-premises identity investments to manage access to cloud-based SaaS applications. You can also use Azure AD to invite external users to your tenant. Azure AD also has business to consumer or B2C features. You can use Azure AD B2C to manage your customers' identities and access. Another great feature of Azure AD is Azure AD Domain Services, or Azure AD DS. You can use Azure AD DS to migrate legacy apps from on-premises to a managed domain without the need to manage the environment in the cloud. As you know, a global administrator or company administrator can access most features and services that use Azure Active Directory. Also, only global administrators and privileged role administrators can delegate administrator roles. Let's investigate the roles you can assign to users in Azure AD. These can be categorized into security and authentication administrators, application administrators, cloud administrators, B2C administrators, and corporate administrators. Let's look at some more roles. The Azure DevOps Administrator can manage the Azure DevOps policy to restrict new Azure DevOps organization creation to a set of configurable users or groups. An Azure Information Protection Administrator has all Azure Information Protection Service permissions. Suppose you want a user to be able to manage Azure Active Directory conditional access settings. In that case, you can assign them the Conditional Access Administrator role. What if you want to enable a user to make purchases, manage subscriptions, manage support tickets, and monitor service health? Assign them the role of Billing Administrator. Users with the Exchange Administrator role have global permissions within Microsoft Exchange Online when the service is present. Directory readers can read basic directory information. Groups Administrator can create and manage groups and their settings like naming and expiration policies. You can sign up for Azure directly through the Azure portal, either with the help of a Microsoft representative or through a Microsoft partner. You can also create a free Azure account. Knowing how billing works and the options to track costs based on your needs is imperative. There are different Azure support options available too. You need an Azure Active Directory, Azure AD tenant, to build apps that use the Microsoft Identity Platform for identity and access management. In the Azure AD tenant, you register and manage your apps, configure their access to data in Microsoft 365 and other web APIs, and enable features such as conditional access. How does Azure AD Connect integrate your on-premises directories with Azure AD? Azure AD Connect integrates your on-premises directories with Azure AD using features such as password hash synchronization, pass-through authentication, federation integration, synchronization, health monitoring. Azure AD Connect Health provides robust monitoring of your on-premises identity infrastructure. Is the deployment of Azure AD Connect Health complicated? No. It's as simple as installing an agent on each of your on-premises identity servers. Azure AD Connect Health helps ensure the environment's reliability when you achieve hybrid identity by deploying Azure AD Connect in your organization. Let's summarize. In this video, you reviewed your knowledge about Azure AD, its benefits, features, and how it's deployed. You learned that Azure AD offers various licensing options, each tailored to meet the needs of different organizations. Understanding the terminology and licensing structures is essential to maximize this powerful identity and access management solution. With a wide array of features, Azure AD streamlines user provisioning, enhances security, and simplifies application access across the cloud environment. It empowers businesses of all sizes to achieve seamless integration and improved productivity. Investigating the roles available in Azure AD helps organizations assign appropriate responsibilities to users. This critical step ensures proper governance and security, creating a robust foundation for user management. To start with Azure AD, you must create an Azure AD tenant. This centralized hub is the foundation for efficiently managing users, groups, and resources. For organizations with on-premises Active Directory, deploying Azure AD Domain Services extends the functionalities into the cloud. It bridges the gap between on-premises and cloud environments, enabling a seamless experience for users. Azure AD Connect integrates your on-premises directories with Azure AD. Azure AD Connect Health provides robust monitoring of your on-premises identity infrastructure. Hello, and welcome to the video, Create and Manage Users in Azure Active Directory. In this video, you'll refresh your knowledge about creating and managing users in Azure AD. You'll revisit the process of assigning and removing licenses. You'll also recall how to update, delete, and restore users. You'll also recall some of the default user permissions. First, let's learn how to add a user. Remember, you must be a user administrator or a global administrator to add or delete users from an Azure AD tenant. How do you add a user? First, sign into the Azure portal as a user administrator. Then navigate to the Users option in Azure Active Directory and select the Create New User option. You can now enter the user's information on the New User page. In the username field under Identity, add the username. Select the domain. Use the default domain name, such as yourdomainname.onmicrosoft.com or custom domain name, contoso.com. In the name field under Identity, enter the display name of the user. Username and name are mandatory fields. Next, add the user to one or more existing groups. In Settings, you'll find a toggle option to block sign-in for the user. You can also set the user's default location. The opportunity to block sign-in may be useful in situations when a user's account is compromised. In the Job Info section, you can add the user's job title, department, company name, and manager. You can update these details at any time. Copy the auto-generated password provided in the password box and share it with the user for their first sign-in. Select Create. Users created in your organization have credentials that can be managed by administrators or the users themselves in case of a forgotten password. Suppose your organization has a subscription to Office 365. You can provide the user with a mailbox and exchange online. This will have an email address that includes a domain name owned by your organization. Let's move to the second set of users, B2B users. To add guest users, you can select the Invite User option on the New User page instead of the Create User option. When you invite a guest user to your tenant, you provide the email address of the recipient and a message describing the invitation. The process of inviting a guest is the same as adding a new user, with two exceptions. The email address will follow different domain rules than users from your organization. You can also include a personal message. Let's now move to the third user category, B2C users. They may be consumers of some of the services you provide. There might be scenarios where you want to create consumer accounts in your Azure AD B2C directory manually. You can do this in the Azure portal, but through a different screen. On the portal settings Directories plus Subscriptions page, find your Azure AD B2C directory in the directory name list and select Switch. You will then choose Azure AD B2C from the left menu and create a new user. How will you delete a user? You'll sign into the Azure portal using one of the appropriate roles to delete a user. You'll then access the Users option. Search for and select the user you want to delete from your Azure AD tenant. After this, you'll choose the Delete User option. Once you delete a user, the user no longer appears on the Users All Users page. The user can be seen on the Deleted Users page for the next 30 days and can be restored during that time. When you delete a user, any licenses consumed by the user are made available for other users. Let's now look at how to assign a license to a user. Before you assign a license to a user, check if you have specified the usage location, else the license cannot be assigned. On the All Products page, select the name of the license plan you want to assign to the user. Then select Assign. Next, on the Assign License page, select Add Users and Groups. Then search for and select the user who requires the license. Next, select the Assignment Options tab and ensure you have the appropriate license options turned on. Then, select the Review plus Assign tab and select Assign. The user is now added to the list of licensed users and has access to the included Azure AD services. You can also assign licenses directly to a user from the User's Licenses page. If a user has a license assigned through a group membership and you want to assign the same license to the user directly, it can be done from the All Products page. Next, let's look at how to assign a license to a group. Similar to assigning a license to a user, select Users and Groups on the Assign License page. Then search for and select the group you're assigning the license to. Next, ensure you have the appropriate license options turned on and select Assign. The group is now added to the list of licensed groups, and all the group members have access to the Azure AD services. Sometimes you have to remove licenses to certain features and tools that users and groups no longer need. Let's learn how to remove licenses for users and groups. You can remove a license from the Group Overview page for a group assignment or the Azure AD Licenses page. To remove a license from a user, first on the All Products page, select a license plan. Then on the Licensed Users page, select the user for whom you want to remove the license. Next, select Remove License. To remove a license from a group, on the Licensed Group screen, select the group that no longer requires the license. Then select Remove License. When new users are created, if the management requires more details, you can update the profile anytime after the user is created. Let's look at how to add or update user profile information. First, sign into the Microsoft Azure portal in the User Administrator role. Next, go to Azure Active Directory and select Users. Then select a user for whom you want to update the profile. There are two ways in which you can edit a user's profile details. You can select Edit Properties from the top of the page, or you can select the Properties tab. Let's recall what happens when a user is deleted. Once you delete a user, their account remains suspended for a 30-day window. The user's organization information is preserved and can be restored during that period. After the 30-day window passes, the permanent deletion process automatically begins and cannot be stopped. The management of soft deleted users is blocked during this process. Remember that you must be a global administrator or a user administrator to be able to restore or permanently delete users. Let's look at where you can view the list of restorable users. First, go to Azure Active Directory and select Users. Then select Deleted Users Preview to view the list of restorable users. To restore a user, first on the Deleted Users Preview page, search for and select the desired user to be restored. Then select Restore Users. Can you permanently delete a user in the first instance without having a 30-day window? Yes, you can. However, please remember that neither a global administrator nor the customer support of Microsoft can restore a permanently deleted user. You'll have to create a new user and manually enter all the previous information if you permanently delete a user erroneously. To permanently delete a user, first on the Deleted Users Preview page, search for and select the desired user to be deleted. Then select Delete Permanently. Members and guest users have different default permission sets. Even though these accounts have default permissions, you can restrict the permissions depending on the situation. Object ownership comprises permissions granted to the application registration owner, enterprise application owner, and group owner. Member users have specific permissions in Azure AD over owned objects. Let's summarize what you covered in this video. You explored how to create and manage users in Azure AD. You revisited the process of assigning and removing licenses. You then reviewed how to update, delete, and restore users. You also explored some of the default user permissions. Hello, and welcome to the video, Manage Groups and External Users in Azure Active Directory. In this video, you'll refresh your knowledge about creating and managing groups and external users in Azure AD. You'll also revisit the administrative roles in Azure AD and how to add a group to an administrative unit. You'll also recall how to manage external collaboration and invite external users. Azure AD provides several ways to manage access to resources, applications, data, and tasks. One of the ways is to use Azure AD Groups. So when should you use Azure AD Groups? Azure AD Groups manage users who require the same access and permissions to resources, such as potentially restricted apps and services. Using AD Groups, you can grant access and special permissions to a group of users instead of to each user. Azure AD lets you use groups to manage access to resources, applications, data, and tasks. Let's look at the different group types and membership types. There are two group types, Security and Microsoft 365. The three group membership types are Assigned, Dynamic User, and Dynamic Device. So how does access management work in Azure AD? Azure AD gives you two options to provide access to your organization's resources: by providing access rights to a single user or by providing access rights to an entire Azure AD group. After creating a group and knowing the options available, you need to decide how to assign access rights. There are four ways to assign access rights: direct assignment, group assignment, rule-based assignment, and external authority assignment. The Azure AD roles that can manage groups are Groups Administrator, User Administrator, Privileged Role Administrator, and Global Administrator. You can create groups to provide access and special permissions to all group members instead of individual users. Who will administer these users? You learn that the various administrative roles can be categorized into security and authentication administrators, application administrators, cloud administrators, B2C administrators, and corporate administrators. Assigning the global administrator role to at most 5 users is recommended. You can assign other administrators for purposes such as adding or changing users, assigning administrative roles, resetting user passwords, managing user licenses, and managing domain names. You must have a global administrator, privileged authentication administrator, or user administrator role assignment to delete users in your organization. Global administrators and privileged authentication administrators can delete any users, including other administrators. User administrators can delete non-admin users, help desk administrators, and other user administrators. How can you simplify administration? You can streamline administration by creating and managing Azure AD groups. Creating groups of users based on their roles or function makes it easier to assign or remove permissions. The following tasks can be performed in Azure AD to streamline the process: create a group and add members and owners, add members and owners to an existing group, remove members and owners from an existing group, add a group to another group, remove a group from another group, and delete a group. Recall that an administrative unit is an Azure AD resource that can be a container for other Azure AD resources. It can only contain users, groups, or devices. You can use administrative units to restrict role permissions to a specific portion of your organization. The key point to remember about administrative unit is that when you add a group to an administrative unit, the group is brought into its management scope, not the group members. Although you can manage the name and membership of the group, you cannot manage user properties and user authentication methods for group members. You cannot reset the passwords of the group members either. For you to be able to manage user properties or user authentication methods, the group members must be directly added as members of the administrative unit. Azure AD B2B collaboration is a feature that allows users to invite guest users to collaborate with their organization. With B2B collaboration, you can securely share your company's applications and services with external users while controlling your corporate data. Azure AD External Identities makes it possible to allow people outside the organization to access apps and resources. In contrast, the organization controls access to the apps with Azure AD to protect the resources. There are different states of external users' accounts, and Azure AD supports various scenarios. The B2B collaboration scenario allows users to invite external users into their tenant as guests and assign permissions while letting them use their existing credentials. As a user assigned to any of the limited administrator directory roles, you can add a guest user to the directory using the Azure portal. You can also invite external users to Azure AD and add them to a group or an application. However, ensure that your organization's external collaboration settings are configured to allow you to invite guests. By default, all users and admins can invite guests. Let's summarize what you covered in this video. You learned how to manage Azure AD groups efficiently. You also learned about the key administrative roles, integrating groups into administrative units, and inviting external users. Hello, and welcome to the video, Manage Secure Access in Azure Active Directory. In this video, you'll refresh your knowledge on authentication, password management, and multi-factor and passwordless authentication. Let's begin with the authentication methods available in Azure Active Directory or Azure AD. A password is usually the primary authentication method. To increase the security of passwords, you can increase the security of sign-in events using Azure AD multi-factor authentication. Passwords have high usability and availability, but are not very secure. You can make your password secure by combining them with an OTP or authentication through a push notification, but this reduces their usability and availability. Therefore, it's better to go passwordless. You could choose authentication through a phone sign-in, Windows Hello, FIDO2, security key, or certificates. Microsoft Authenticator app is recommended for flexibility and usability. It provides multiple modes like passwordless, multi-factor authentication push notifications, and oath codes, which we will discuss in this video. Let us quickly discuss Windows Hello. Windows Hello is set up on the user's device, and Windows asks the user to set a gesture, which can be a biometric such as a fingerprint or a PIN. The user provides the gesture to verify their identity. Windows then uses Windows Hello to authenticate users. Next, through Fast Identity Online or FIDO Alliance, users can register and then select a FIDO2 security key at the sign-in interface as their main means of authentication. The FIDO2 security keys are USB devices, but could also be used through Bluetooth or NFC. Moving on, let's talk about measures you can take to protect passwords in Azure AD. A password policy is applied to all user and admin accounts created and managed directly in Azure AD. You can ban weak passwords and define parameters to lock out an account after repeated bad password attempts. Asking users to comply with certain requirements can make passwords more secure. These requirements can include uppercase characters, lowercase characters, numbers from 0 to 9, symbols as displayed on the screen, blank space, password length. By default, passwords have an expiration date. A global administrator or user administrator can use the Microsoft Azure AD module for Windows PowerShell to set user passwords not to expire. Such password protection measures in Azure AD help ensure your organization's security. When we talk about banned passwords, we have two types of banned password lists, global and custom banned. In the case of global banned password lists, the Azure AD Identity Protection team looks for terms that often serve as the basis for weak passwords. When such weak terms are found, they're added to the global banned password list and are used to validate the new password strength. In the case of custom banned password lists, some organizations add their own customizations in addition to the global banned password list to improve security. The custom banned password list works alongside the global banned password list to enforce strong passwords in such organizations. Moving on, let's discuss Azure AD Self-Service Password Reset or SSPR, which allows users to change or reset their password without an administrator or the help desk's involvement. If Azure AD locks a user's account or they forget their password, they can follow prompts to unblock themselves and log in. This ability reduces help desk calls and loss of productivity when a user can't sign into their device or an application. When a user is enabled for SSPR, they must register at least one authentication method. Let's quickly revisit the concept of multi-factor authentication. A second layer of identification increases security. Multi-factor authentication is a process in which a user is prompted for additional forms of identification during a sign-in event. For example, the prompt could be to enter a code on their mobile device or to provide a fingerprint scan. You can also enable multi-factor authentication with conditional access to make the solution fit the specific needs of your organization. These policies allow you to prompt users for multi-factor authentication when needed for security and stay out of users' way when not needed. Conditional access policies can be applied to specific users, groups, and apps. You can define the cloud apps or actions that trigger the conditional access policy. Multi-factor authentication is a great way to secure your organization, but passwordless authentication is more convenient. The password is removed and replaced with something you have, like a Windows 10 device, phone, or security key, with something you are or something you know, such as biometric or PIN. Each organization has different needs when it comes to authentication. Microsoft offers 3 passwordless authentication options that integrate with Azure AD. Those are Windows Hello for Business, Microsoft Authenticator app, and FIDO2 security keys. Passwordless authentication has some key benefits. Firstly, it is more secure. You can reduce the risk of phishing and password spray attacks by removing passwords as an attack surface. Secondly, it allows a better user experience and gives users a convenient way to access data from anywhere. It also provides easy mobile access to applications and services such as Outlook, OneDrive, or Office. Thirdly, it gives robust insights. You can gain insights into users' passwordless activity with robust logging and auditing. Let's conclude the recap video. To summarize, the video refreshed your knowledge on various authentication methods, password management, and multi-factor and passwordless authentication. Hello, and welcome to the video, Explore Authentication Options for Hybrid Identities. In this video, you'll refresh your knowledge of authentication options for hybrid identities. Let's begin with hybrid identities. Microsoft's identity solutions span on-premises and cloud-based capabilities. These solutions create a common user identity for authentication and authorization to all resources regardless of location. This is what you call hybrid identity. You do this to enable a single account to access resources on-premises and in the cloud. As a security engineer, you can use hybrid identity to share identity, authentication, and access across on-premises and cloud resources. So what do you need to do to use hybrid identity? First, connect your on-premises Active Directory or AD with your Azure AD. Then select the best authentication option based on your user's needs and your security goals. Lastly, configure authentication options to create your most secure environment. There are 3 authentication methods through which you can achieve hybrid identity with Azure AD: password hash synchronization, pass-through authentication, and federated authentication. Let's look at each of these methods in detail. Azure AD password hash synchronization is the simplest way to enable authentication for on-premises directory objects in Azure AD, as you don't have to deploy any additional infrastructure for authentication. Azure AD Connect synchronizes a hash of a user's password from an on-premises Active Directory instance to a cloud-based Azure AD instance. Your users can use the same credentials that they use on-premises. Let's have a look at its benefits. Password hash synchronization helps you to improve users' productivity and helps you to reduce help desk costs. Moving on to the second method, Azure AD pass-through authentication. It provides a simple password validation for Azure AD authentication services using a software agent on one or more on-premises servers. The servers validate the users directly with your on-premises Active Directory, ensuring password validation doesn't happen in the cloud. This feature is an alternative to Azure AD password hash synchronization, which provides the same benefit of cloud authentication to organizations. Let's have a look at 6 benefits of pass-through authentication. Firstly, it supports user sign-in to all web browser-based applications and Microsoft Office client applications that use modern authentication. Secondly, it supports sign-in with usernames that are either the on-premises default username or another attribute configured in Azure AD Connect, also known as an alternate ID. Thirdly, it works seamlessly with conditional access features such as Azure Active Directory multi-factor authentication to help secure your users. Fourthly, it's integrated with cloud-based self-service password management. This feature includes password write-back to on-premises Active Directory and password protection by banning commonly used passwords. Fifthly, it supports multi-forest environments if forest trusts exist between your AD forests and name suffix routing is correctly configured. Lastly, it protects your on-premises accounts against brute force attacks in the cloud. The third method is federated authentication. When you choose this method, Azure AD hands off the authentication process to a separate trusted authentication system, such as on-premises Active Directory federation services to validate the user's password. This sign-in method ensures that all user authentication occurs on-premises. AD Federation Services, or ADFS, offers simplified secured identity federation and web single sign-on capabilities. What are some benefits of deploying ADFS? First, it offers high availability. With the power of Azure availability sets, a highly available infrastructure is ensured. Second, it's easy to scale. Need more performance? Easily migrate to more powerful machines with just a few clicks in Azure. Third, it offers cross-geo redundancy. With Azure Geo Redundancy, you can be assured that your infrastructure is highly available globally. Lastly, it is easy to manage, with highly simplified management options in the Azure portal. Managing your infrastructure is easy and hassle-free. Next, let's revisit the concept of achieving hybrid identity by deploying Azure AD Connect. Azure AD Connect is an on-premises Microsoft application designed to meet and accomplish your hybrid identity goals. It allows you to provide a common identity for your users for Microsoft 365, Azure, and Software as a Service, or SaaS, applications integrated with Azure AD. It's a good idea to use Azure AD Connect for synchronizing on-premises identities and objects with Azure AD. Azure AD Connect comes with many features. First, you can use it to create users, groups, and other objects. Second, you can also use it to ensure identity information for your on-premises users and groups matches the cloud. Third, Azure AD Connect synchronizes a hash of a user's password from an on-premises Active Directory instance to a cloud-based Azure AD instance. Fourth, you can also opt for pass-through authentication. It allows users to use the same password on-premises and in the cloud, but doesn't require the additional infrastructure of a federated environment. Lastly, federation is an optional part of Azure AD Connect and can be used to configure a hybrid environment using an on-premises AD Federation Services infrastructure. Let's move on and focus on the factors that you must consider while deciding the authentication method for your organization. There are several factors you must consider. Does the effort to deploy the solution and the user's experience of the sign-in process address your business requirements? Does your organization need each authentication method's advanced scenarios and business continuity features? Finally, evaluate the considerations of each authentication method. Do any of them prevent you from implementing your choice? After considering these factors, select an authentication method that meets your organization's business, security, and technical requirements. Next, let's revisit Password Writeback. Password Writeback is a feature of Azure AD Connect. Once it's enabled, users can reset their passwords in Azure AD and have the new password synchronized in real time back to the on-premises AD. This feature is particularly useful for organizations that have a hybrid environment where they have both cloud and on-premises applications. The authentication methods could be federation, password hash synchronization, or pass-through authentication. Let's conclude the recap video. To summarize, the video covered a detailed explanation of hybrid identity, authentication methods, Azure AD Connect and its features, and Password Writeback.
Hello, and welcome to the recap of Course 2, Identity Protection and Governance. In this video, explore Azure Active Directory Identity Protection. You will refresh your knowledge on identity protection, risk-based policies, and conditional access. Let us begin with revisiting the concept of identity protection. Identity protection is a tool that allows organizations to automate the detection and remediation of identity-based risks, investigate risks using data in the portal, and export risk detection data to third-party utilities for further analysis. Now, in the context of Azure AD, identity protection is a solution built into Azure AD that is designed to protect your identities through a three-part process, that is, detect, investigate, and remediate. So, to avoid risks, which are suspicious activity and actions by users when they sign in or when they take actions after signing in, your organization can use identity protection without hiring expensive security experts. Risks are categorized as user risks and sign-in risks. User risk is caused when a user's identity or account is compromised. User risks can include unusual behavior or leaked credentials. In a sign-in risk, identity protection scrutinizes each authentication request to judge whether it was authorized by the owner of the identity. Sign-in risks can include unfamiliar sign-in properties, atypical travel, malware-linked IP address, or anonymous IP address. Let us move on to workflows that are used to detect and handle identity risks. There are two types of workflows: self-remediation workflow and administration remediation workflow. Self-remediation workflow is a workflow where the administrator first configures the risk policies that then monitor for identity risks. If any risk is detected, the policies enforce measures to remediate it. Administrator remediation workflow allows the admin to configure risk policies. This remediation workflow helps you to make more fitted decisions. Here, the admin understands the context in which the risks were detected. Then, the policies monitor for identity risks, and the admin is notified of risks in a report where he takes suitable actions to remediate the risks. Next, let us look at risk-based policies in Azure AD that help to protect users and respond to suspicious activities. Let us look at the actions that may trigger Azure AD identity protection risk detection. Users with leaked credentials, sign-ins from anonymous IP addresses, impossible travel to atypical locations, sign-ins from infected devices, and sign-ins from IP addresses with suspicious activity. 3 such policies are: User Risk Policy. Identity protection learns the user's standard behavioral patterns to calculate the likely risk that the user's identity was compromised. Based on this risk, the admin can decide whether to allow access, block it, or allow access only after additional requirements are met. Sign-in Risk Policy. It scrutinizes every sign-in and gives it a risk score. This score indicates the probability that the person whose credentials are used attempted to sign in. Based on the risk level set by you, you can allow access, automatically block, or allow access only after additional requirements are met. Multifactor Authentication Registration Policy. It ensures all users are registered for Azure AD multifactor authentication. With multifactor authentication, the user must go through an additional verification step after successfully providing their username and password. Multifactor authentication registration adds a second layer of protection to your user's identities. The security of multifactor authentication's two-step verification lies in its layered approach. Let us quickly go through the critical features of multifactor authentication. It gives more security with less complexity. It mitigates threats with real-time monitoring and alerts. It can be used with Microsoft 365, Salesforce, Azure AD Premium, and thousands of software as a service, also called SaaS applications. Lastly, it adds protection for Azure administrator accounts without additional costs. It is time to move on to conditional access. It is the tool Azure AD uses to bring signals together, make decisions, and enforce organizational policies. It is at the heart of the new identity-driven control plane. Talking about the conditional access policy, it is a next-generation policy built for the cloud. It can consider massive amounts of data and contextual data from a user's sign-in flow and ensure that the right controls are enforced. Conditional access policies, at their simplest, are if-then statements. When do the conditional access policies come into play? Conditional access policies are enforced after the first factor authentication has been completed. Conditional access is not intended as an organization's first line of defense for scenarios like denial of service, frequently referred to as DOS attacks, but can use signals from these events to determine access. Moving on, let us talk about access reviews. Azure AD Access Reviews allow organizations to efficiently manage group memberships, access to enterprise applications, and role assignments. There are some scenarios when it becomes important to use access reviews. Those are when there are too many users in privileged roles, when automation is infeasible, when a group is used for a new purpose, when data access is critical for business, when you need to maintain a policy's exception list, when you need to ask group owners to confirm if they still need guests in their groups, and lastly, when you need to have reviews recur periodically. Lastly, let's discuss about how you can investigate risks. There are two kinds of possible reports: risky sign-ins and risky users. Risky sign-ins reports include location details, device details, and sign-ins confirmed as a safe or dismissed or remediated risks. The admin can then confirm that sign-ins are safe or compromised. The reports cover the last 30 days. Risky user reports include lists of at-risk users and users with dismissed or remediated risks. They also cover the user history of risky sign-ins. The admin can then reset user passwords, dismiss user risk, block user sign-ins, and confirm user accounts as compromised. When your investigation is complete, you'll want to remediate the risks if you're not already using risk policies to deal with them automatically. To remediate the risks, you can use the method of self-remediation. You can reset passwords manually. You can dismiss user risk detections. You can also close individual detection. With this, we have come to the end of this video. Let's conclude the recap video. To summarize, the video covered a detailed explanation of identity protection, types of risks, workflows, risk-based policies, features of multifactor authentication, conditional access policy, access reviews, and investigating and remediating risks by talking about types of reports and methods of remediating risks. Hello, and welcome to the video, Manage Privileged Access Using Privileged Identity Management. In this video, we will talk about Azure Active Directory Privileged Identity Management, frequently called Azure AD PIM, the Zero Trust Model, Microsoft Identity Manager, PIM Workflows, and PIM for Groups. Let us start by revisiting the concept of Azure AD PIM, which allows you to manage, control, and monitor access to the essential resources in your organization. As an Azure security engineer, you can use PIM to protect administrator privileges and mitigate the risk of excessive or misused access rights. PIM enables you to allow specific actions at a particular scope. Key features of PIM include providing just-in-time privileged access to resources, assigning eligibility for membership or ownership of PIM for groups, assigning time-bound access to resources using start and end dates, requiring approval to activate privileged roles, enforcing multifactor authentication to activate any role, using justification to understand why users activate, getting notifications when privileged roles are activated, conducting access reviews to ensure users still need roles, downloading audit history for internal or external audit, and preventing the removal of the last active global administrator and privileged role administrator role assignments. You can use PIM with Azure Active Directory or Azure AD roles, sometimes called directory roles. Azure AD roles include built-in and custom roles to manage Azure AD and other Microsoft 365 online services. You can use PIM with Azure roles. The Role-Based Access Control, or RBAC roles in Azure, grants access to management groups, subscriptions, resource groups, and resources. Lastly, you can use PIM for groups. PIM for Groups not only gives you an alternative way to set up PIM for Azure AD roles and Azure roles, but also allows you to set up PIM for other permissions across Microsoft Online Services, like Intune, Azure Key Vaults, and Azure Information Protection. You can assign the following to these roles or groups. Users, to get just-in-time access to Azure AD roles, Azure roles, and PIM for groups. Groups, anyone in a group to get just-in-time access to Azure AD roles and Azure roles. For Azure AD roles, the group must be a newly created cloud group marked as assignable to a role, while for Azure roles, the group can be any Azure AD security group. Next, let us understand the two types of assignments, eligible and active. Eligible assignments require the role member to perform an action to use the role. Actions must include activation or requesting approval from designated approvers. Active assignments don't require the member to perform any action to use the role. Members assigned as active have the privileges assigned to the role. Let us move on to the Zero Trust model. This model is based on the Never Trust, Always Verify principle. Zero Trust helps secure corporate resources by eliminating unknown and unmanaged devices and limiting lateral movement. Zero Trust verifies the identity and device health before granting corporate resource access. Implementing a true Zero Trust model requires all components, user identity, device, network, and applications, to be validated and proven trustworthy. When access is granted, applying the principle of least privilege limits user access to only those resources that are explicitly authorized for each user, thus reducing the risk of lateral movement within the environment. In an ideal Zero Trust environment, 4 elements are necessary. First, strong identity authentication exists everywhere. Second, the devices are enrolled in device management and their health is validated. Third, least privilege user rights are granted. Fourth, the health of services is verified. Next, let us revisit digital identity. A digital identity combines who you are and what you can do. Credentials, that is, who you are, and privileges, that is, what you are allowed to do, together make your digital identity. Securing privileged identities is critical to establishing security assurances for business assets in a modern organization. Hence, you must help protect your privileged accounts. Microsoft Identity Manager, frequently called MIM, helps organizations manage users, credentials, policies, and access within their organizations and hybrid environments. With MIM, organizations can simplify identity lifecycle management with automated workflows, business rules, and easy integration with heterogeneous platforms across the data center. Identity management approaches have evolved from traditional to advanced to optimal. Moving on, let us discuss PIM workflow. You can manage role-based access at the resource level. Elevated access includes job roles that need greater access. You should rationalize new requests for elevated access and perform regular reattestation for elevated roles because elevated access accounts could be misused if compromised. By creating PIM workflows, administrators can ensure that privileged access is granted only when necessary, that it's reviewed regularly to prevent unauthorized access, and that it's automatically revoked when no longer needed. Workflows help increase the security of critical applications and the Azure resources the applications access, thus making the environment more secure. Next, let us revisit the Azure AD roles managed in PIM. PIM lets you assign users to common administrator roles, including Global Administrator, Privileged Role Administrator, Billing Administrator, Password Administrator, Service Administrator, User Management Administrator, Exchange Administrator, SharePoint Administrator, and Skype for Business Administrator. Talking about Azure roles, these roles are linked to an Azure resource, resource group, subscription, or management group. PIM provides just-in-time access to built-in roles like owner, user access administrator, and contributor, as well as custom roles. PIM for groups is part of Azure AD PIM, alongside PIM for Azure AD roles and PIM for Azure resources. PIM for Groups enables users to activate the ownership or membership of an Azure AD security group or Microsoft 365 group. Groups can be used to govern access to various scenarios, including Azure AD roles, Azure SQL, Azure Key Vault, Intune, other application roles, and third-party applications. With PIM for Groups, you can use policies like those in PIM for Azure AD roles and PIM for Azure resources. For example, you can require approval for membership or ownership activation, enforce multifactor authentication, require justification, limit maximum activation time, and more. Each group in PIM for Groups has 2 policies, one for activation of membership and another for activation of ownership in the group. With this, we have come to the end of this video. Let's summarize. In this video, you reviewed key concepts of Azure AD PIM, features of PIM, uses of PIM, types of assignments, Zero Trust model, Microsoft Identity Manager, PIM workflow, and PIM for Groups. Hello, and welcome to the video Designing an Enterprise Governance Strategy, Principles and Policies. In this video, you'll review the core principles of enterprise governance and policies. An entity utilizing hardware and software within its premise holds complete accountability for enforcing security and compliance measures. It is essential to understand the division of shared responsibilities between you and Microsoft regarding software as a service, SaaS, platform as a service, PaaS, infrastructure as a service, IaaS, or an on-premises data center. There are 3 categories for the shared responsibilities model. Responsibility that the customer always retains, responsibilities that vary by type, and responsibilities that get transferred to the cloud service provider. However, regardless of the type of deployment, you will always retain responsibility for information and data, endpoints, devices, mobiles and personal computers or PC, accounts and identities, and access management. Next, let's review the cloud security advantage. The cloud offers significant advantages for solving long-standing information security challenges. This diagram shows a traditional approach where many security responsibilities are unmet due to limited resources. You can categorize the traditional approach in terms of satisfied responsibility, partially met responsibility, and unmet responsibility. While in the cloud-enabled security approach, you can shift day-to-day security responsibilities to your cloud provider and reallocate your resources. Cloud technology enables security in 4 ways. First, by moving commodity responsibilities to the provider and reallocating your resources. Second, by leveraging cloud-based security capabilities for more effectiveness. Third, by using cloud intelligence to improve detection or response time. And fourth, by sharing duties with the provider. Azure provides value in 3 key areas: secure foundation, built-in security controls, unique intelligence. Now, what is Azure's security policy? Azure Security Policy is a set of rules and configurations that define the desired security posture for your Microsoft Azure resources. It helps organizations manage and enforce security requirements in the Azure cloud environment. Azure Security Policies are integral to Azure Policy, a service for creating, assigning, and managing policies for Azure resources. A security initiative in Azure is a group of policy definitions or rules that work toward a specific goal or purpose. It simplifies policy management by grouping policies together as a single item. Azure Policy supports compliance states such as non-compliant, compliant, conflict, exempted, and unknown, preview. The Azure policies have the following built-in initiatives: Cosmos DB, guest configuration, Kubernetes, monitoring, network, regulatory compliance, Defender for Cloud, previously Security Center. Azure generates security recommendations by regularly analyzing your resource's compliance status against relevant policies. These recommendations help identify security issues and guide how to fix them. After selecting your initiatives, you'll receive personalized recommendations to help you secure and strengthen your resources. Each recommendation provides you with the following information: a short description of the issue, the remediation steps to carry out to implement the recommendation, the affected resources. Azure Resource Manager, or ARM, is the deployment and management service of Azure. It provides a management layer that enables you to create, update, and delete resources in your Azure account. You can use management features like access control, locks, and tags to secure and organize your resources after deployment. The ARM manages your request when you make it via the Azure portal, Azure PowerShell, Azure Command Line Interface, or Azure CLI, Representational State Transfer APIs, or REST APIs, or Client Software Development Kits, or SDKs. The Azure Resource Manager has 4 levels of scope: Management Group, Subscriptions, Resource Groups, and Resources. The management groups are the Azure resource for building adaptable and practical hierarchies within the framework. Management group hierarchies can be up to 6 levels deep. This allows you to create a hierarchy that combines several of these strategies to meet your organizational needs. For example, the diagram shows an organizational hierarchy that combines a business unit strategy with a geographic strategy: human resources, IT, marketing, apps, production, and geographic regions. That's not all. What is Azure Policy and its requirements? Azure Policy is a service you use to create, assign, and manage policies without cost. These policies enforce different rules and affect your resources. The three main pillars of the Azure Policy are: first, real-time enforcement and compliance assessment. Second, applying policies at scale by leveraging management groups. Third, remediation by leveraging a remediation policy. As you know, many built-in roles grant permissions to Azure Policy resources. For example, the Resource Policy Contributor and Owner roles. To create a custom policy, you should identify your business requirements, then map each requirement to an Azure resource property. Following this, you should map the property to an alias, determine which effect to use, and then compose the policy definition. To compose and implement Azure Policy, you need to create a policy definition or the conditions under which it's enforced, a policy assignment, or the scope within which the definition applies, and policy parameters that help simplify policy management by reducing the number of policy definitions. Each policy definition in Azure Policy has a single effect. That effect determines what happens when the policy rule is evaluated to match. The effects behave differently depending on whether they are for a new, updated, or existing resource. These effects are currently supported in a policy definition: append, audit, audit if not exists, deny, deny action, preview, deploy if not exists, disabled, manual, preview, and modify. The effects can be interchangeable, such as audit, deny, and either modify or append, audit if not exists, and deploy if not exists are often interchangeable. The manual isn't interchangeable. Disabled is interchangeable with any effect. There are several types of built-in policies in Azure: API management, app configuration, app service, automation, compute, container registry, Cosmos DB, general, Key Vault, network, Defender for Cloud, structured query language, SQL, storage, tags. Azure Policy definition structure is a critical component of Azure Policy. It establishes conventions for resources. The definition structure comprises several elements that specify the conditions and effects required for a particular policy. The elements of the Azure Policy definition structure include the following: display name, description, mode, metadata, parameters, and policy rule. Let's summarize. In this recap video, you learned the shared responsibilities model, Azure Cloud Security Advantages, and Azure built-in policies and initiatives. You also learned to review Azure's hierarchy of systems and compliance data of Azure resources. Hello, and welcome to the video, Manage Resources Using Role-Based Access Control. In this video, you will revisit the concepts of Azure Role-Based Access Control, or Azure RBAC, Azure Subscription, built-in roles, and custom roles. Let us begin by understanding the concepts of Azure RBAC. Azure RBAC is an authorized system built on Azure Resource Manager that provides fine-grained access management of resources in Azure. With Azure RBAC, you can grant the exact access that users need to do their jobs. For example, with the help of Azure RBAC, one user can manage virtual machines in a subscription, while another manages structured queried language, or SQL databases, within the same subscription. Before moving forward, let us look at the important aspects of Azure Subscription. Firstly, one Azure subscription is associated with only one Azure AD tenant. Secondly, one resource group can have multiple resources associated with one Azure subscription. Thirdly, resource can be bound to only one resource group. When you provide an Azure subscription to the employee, you should follow these two concerns. Make sure that when employees leave the organization, their cloud access will be removed. Keep the right balance between autonomy and central governance. For example, if an employee is accessing virtual machines in the cloud, his activity should be controlled centrally where the virtual machines connect. Do you remember what you can do with the Azure RBAC? The Azure RBAC allows you to grant access by assigning the appropriate Azure roles to users, groups, and applications at a specific scope. In the role assignment scope, you can view a management group, subscription, resource group, or single resource. Let us also discuss the working of Azure RBAC. The role assignments in Azure RBAC help you control access to resources for their permissions. You need 3 elements: a security principal, a role definition, and a scope to create a role assignment. You can consider these elements as who, what, and where. The security principal, or the who, is a contemporary term for the user, group, or application you would grant access to. The role definition, or the what, is a collection of permissions. Using role definition, you can provide users with read, write, and delete access. Azure has several categories of built-in roles. Out of these, General is the main category. An owner has full access to all resources and the right to delegate access to others. Contributors can create and manage all Azure resources but can't grant access to others. Readers can view existing Azure resources, and User Access Administrator can allow managing user access for Azure resources. The other built-in categories are compute, networking, storage, database, analytics, and so on. If the built-in roles don't meet the specific needs of your organization, you can create your own Azure custom roles. Finally, the third element required to create a role assignment is scope, or the where. It is the set of resources that the principal is allowed to access. This is helpful if you want to make someone a website contributor, but only for one resource group. Now, let us talk about the role assignment. A role assignment is the process of attaching a role definition to a user, group, service principal, or managed identity at a particular scope for the purpose of granting access. Access is granted by creating a role assignment, and access is revoked by removing a role assignment. What can you do with Azure RBAC? Azure RBAC allows one user to manage virtual machines in a subscription and another user to manage virtual networks. It allows a database administrator group to manage SQL databases in a subscription. It allows a user to manage all resources in a resource group, such as virtual machines, websites, and subnets. Lastly, it allows an application to access all resources in a resource group. You can also list and grant access using Azure RBAC and the Azure portal. Let us move on and revisit the primary difference between Azure RBAC and Azure Policy. Azure RBAC manages access to the Azure resources regarding users, areas, and responsibilities. You can assign duties within a team and grant necessary permissions in the Azure resource. Hence, users can do their tasks without interfering with other subscription-related features. Azure Policy helps to enforce governance to make the environment compliant. Azure Policy's focus during deployment is on resource attributes and already existing resources. Next, let us explore custom roles in Azure. Custom roles allow you to define roles that meet your organization's specific needs. You can assign the created Azure custom roles to users, groups, and service principals at different scopes, such as subscription, resource group, or resource. Also, you can create custom roles using the Azure portal, Azure PowerShell, Azure CLI, or the REST API. Who can create or assign the custom roles in Azure RBAC? Users should have roles such as Owner or User Access Administrator to do so. To whom can you assign the custom roles? Custom roles can be assigned to 4 security principals: user, group, service principals, and managed identity. A user is an individual who has a profile in Azure Active Directory. A group is a set of users created in the Azure Active Directory. A service principal is a security identity used by applications or services to access specific Azure resources. A managed identity is an identity in Azure Active Directory that Azure automatically manages. However, for the different scopes, such as subscription, resource group, and individual resource, you can scope the assignment and related permissions to varying levels within Azure. Lastly, let us look at the table to revise the differences between the setup and management of Azure RBAC and Azure AD Administrator roles in terms of resources, scope levels, and role information. Firstly, Azure roles manage access to Azure resources like VMs, storage, and VM networks whereas Azure AD roles manage access to Azure AD resources like user accounts and passwords. Secondly, Azure roles have multiple scopes, such as management group, subscription, resource group, and resource, whereas the scope of Azure AD roles is only at the tenant level. Thirdly, in the case of Azure roles, role information is accessible through the Azure portal, Azure CLI, Azure PowerShell, Azure Resource Manager templates, and REST API, whereas for Azure AD roles, the role information is accessible in the Azure Admin Portal, Microsoft 365 Admin Center, Microsoft Graph, and Azure AD PowerShell. Let's conclude. To summarize, the video covered a detailed explanation of Azure RBAC, Azure Subscription, built-in roles, working of RBAC, custom roles, the difference between Azure RBAC and Azure Policy, and Azure roles and Azure AD roles. Hello, and welcome to the video, Manage and Secure Resources with Resource Locks and Azure Blueprints. In this video, you'll refresh your knowledge on resource locks, Azure Blueprints, and subscriptions. Let us begin by revisiting the concept of Azure Resource Locks. Azure Resource Lock is an Azure feature that helps prevent the deletion or modification of the resources within an Azure tenant. The lock can be applied to subscriptions, resource groups, or individual resources. Azure Resource Locks are of two types. Cannot delete. You can modify and read, but cannot delete the resource group. Read only. You can only read such type of resource, but cannot modify or delete it. Let's revisit the concept of lock inheritance. When you apply a lock to a parent scope, all resources within that scope inherit the same lock. Even resources you add later inherit the same parent lock. The most restrictive lock in the inheritance takes precedence. Locks only apply to control plane Azure operations and not to data plane operations. For example, a read-only lock on an SQL database logical server protects it from deletions or modifications. It allows you to create, update, or delete data in the server database. So, who can create or delete management locks? Only owner and user access administrator built-in roles can create and delete management locks. Else, you can create a custom role with the existing permissions. In addition, you should have access to Microsoft.authorization or Microsoft.authorization/locks action. Moving on, let us look at the resource locks and their security. Resource Manager locks allow administrators to prevent Azure resources from being deleted or modified. These locks sit outside the role-based access control hierarchy, also called RBAC hierarchy, and when you apply them, you will get restrictions on the resource for all the users. Such locks are helpful when you have an essential resource in your subscription. So, how to manage applications and locks? The Azure services, such as Azure Databricks, use managed applications to implement the service. There are two resource groups. Unlocked resource group that contains a service overview. Locked resource group that contains the service infrastructure. It is time to look at some benefits that resource locks offer. By utilizing group resource locks, companies can improve their operational efficiency, reduce the risk of errors and security breaches, meet compliance requirements, and avoid accidental deletions, unauthorized modifications and updates, inconsistent deployments, and resource management difficulties. Note that only users with elevated roles and access can create, manage, or delete resource locks. You must have access to Microsoft.authorization or Microsoft.authorization/locks actions. Of the built-in roles, only owner and user access administrator are granted those actions. However, these access permissions can be granted to other roles. Next, let us move on to Azure Blueprints, which allowed cloud architects and IT groups to define a consistent set of Azure resources that meets an organization's standards and requirements. With Blueprints, development teams can quickly create new environments while ensuring they comply with organizational standards. Blueprints are a declarative way to orchestrate deploying various Azure resource templates and artifacts, such as policy assignments, role assignments, Azure Resource Manager templates, also referred to as ARM templates, resource groups. Lastly, let us discuss subscriptions. Subscriptions are management, billing, and scale units within Azure AD and are hosted in your account's tenant. Subscriptions rely on the trusted Azure AD instance to authenticate and authorize security principals and devices. When subscriptions expire, the trusted instance of the Azure AD service remains, but the security principals lose access to Azure resources. Subscriptions can only trust a single directory, while one Azure AD may be trusted by multiple subscriptions. When you set up a subscription, it's hosted within your Azure AD tenant. You can create additional subscriptions to avoid subscription limits, create separate billing and security environments, or isolate data for compliance. If you want to provide others access to your subscription or its resources, you may invite them to join your tenant. Doing so helps you manage and control access. To create Azure subscriptions under your organization's enterprise agreement, or EA, one of your roles must be account owner. If you need to change the billing ownership of your Azure subscription, transfer the billing ownership. Transferring ownership allows the account's new administrators to handle billing tasks, such as updating payment methods, checking charges, and canceling the subscription. Only billing account administrators can transfer subscriptions. How will subscription management help you? It supports cost control, resource optimization, security and compliance, scalability and agility, and governance and accountability. What should you consider when designing a subscription management plan? Microsoft offers recommendations for these areas: organization and governance, quota and capacity, automation, tenant transfer restrictions. Let's summarize. In this video, you refresh your knowledge on resource locks, types of resource locks, scope for locks, and resource group. You also revisited the Azure Blueprints and subscriptions management plans.
Hello, and welcome to the video Implement Perimeter Security Strategies. In this video, you'll thoroughly refresh your knowledge of the concepts of defense in depth and secure solutions using distributed denial of services, DDoS protection, firewalls, and VPNs. Let's begin with the concept of defense in depth. Defense in depth is a strategy where you implement multiple security measures to protect the organizational resources and digital assets against various threats. For example, multiple layer security in case of a cyber threat is locking down the perimeter first and then working your way inward, locking down each layer. Defense in depth benefits the organization where Microsoft Azure offers unified security management and Microsoft Defender for Identity, formerly known as Advanced Threat Protection or ATP, for your resources in the cloud and on-premises. It has several access controls. These are Azure Network Security Groups, Application Security Groups, Azure Web Application Firewall or WAF, and the Azure Firewall and Local Admin Password Solution. What is a network client? A network client is a lightweight computer or device that can't run programs independently. It's used to access and interact with a mainframe computer. You can use client-server models such as request-response, peer-to-peer, or P2P model, and published-subscribe. 3 types of clients are used in a client-server configuration: thick, hybrid, and thin. What is firewall and network security? Firewalls are gatekeepers between internal or private networks and the internet or public networks. Its primary purpose is to establish a barrier between a secure and controlled internal network and the outside world, which may not be safe or trustworthy. Firewalls also serve different functions on your network, requiring different types of firewalls, such as application layer firewalls, packet filtering firewalls, circuit-level firewalls, proxy server firewalls, stateful firewalls, and next-generation firewalls. Network security encompasses policies and practices to prevent and monitor unauthorized access, misuse, modification, or denial of a computer network and network-accessible resources. It has several strategies: access control, anti-malware tools, application security, behavioral analytics, email security, intrusion detection and prevention, VPN, web security, and wireless security. On the other hand, a virtual network is a representation of your network in the cloud. It's a logical isolation of the Azure Cloud Network dedicated to your subscription. Virtual networks are made up of subnets. A subnet is a range of internet protocols or IP addresses within the virtual network. These IP addresses are private and public. You can implement multiple virtual networks within each Azure subscription and Azure region. What's network monitoring? Network monitoring can be agent-based and agentless, and it monitors each of the components of a network like switches, routers, servers, and firewalls. Network management follows certain protocols such as Simple Network Management Protocol, SNMP, Windows Management Instrumentation, WMI, and System Logging Protocol, syslog. The perimeter networks, frequently referred to as demilitarized zones or DMZs, help provide secure connectivity between cloud networks, on-premises, or physical data center networks, and the internet. In secure perimeter networks, incoming packets flow through security appliances hosted in secure subnets before the packets can reach backend servers. Let's look at the diagram for perimeter network topology. What's more, the denial of service, or DOS, is an attack that aims to prevent access to services or systems and originates from one network, while DDoS originates from multiple networks and systems. DDoS contains best practices that are helpful for your networks, such as security should be a priority throughout the lifecycle of an application. Design your applications to scale horizontally and layer security defenses in an application. That's not all. Azure Firewall is a managed cloud-based network security service that protects your Azure Virtual Network resources. There are 4 premium features for Azure Firewall: Transport Layer Security, TLS, Intrusion Detection and Prevention System, IDPS, URL filtering, and Azure Firewall's web categories. What is Azure Firewall Manager? It enables you to centralize the management of multiple instances of Azure Firewall. By implementing Azure Firewall, you can help protect your Azure resources and root management for your cloud-based security perimeters. What else? A network virtual appliance, or NVA, comprises various layers such as a firewall, a wide area network, or WAN, optimizer, application delivery controllers, routers, load balancers, intrusion detection, IDS, or intrusion prevention systems, IPS, and proxies. Configure VPN force tunneling lets you redirect or force each internet-bound traffic back to your on-premises location via a site-to-site VPN tunnel for inspection and auditing. This is a critical security requirement for most enterprise IT policies. How do you use virtual network peering to connect Azure virtual networks directly? The reciprocal connections, cross-subscription virtual network peering, and directly peered virtual networks can communicate with Azure virtual networks. That's it. Let's summarize. In this video, first you learned about the concept of defense in depth, network client and server technology, firewall and network security, and virtual network security. Then you learned perimeter networks, or DMZs, DDoS protection, Azure Firewall features, and Azure Firewall Manager. And lastly, you learned network isolation security, VPNs, NVAs, virtual network peering, and VPN gateways. Hello, and welcome to the Configure Network Security Groups. In this video, you'll thoroughly refresh your knowledge of deploying and configuring network security groups. Let's begin with network security as a part of defense strategy. Network security is vital in the defense strategy. You can create a virtual machines, or VMs, with 2 models. One is the Resource Manager Deployment model, where VMs are shielded from the internet and can connect directly to it using a public IP address. In this model, network security groups, NSGs, can be assigned to a network adapter to control traffic. And the second is the classic deployment model, where VMs communicate with the internet through a cloud service with a public virtual IP address, also called VIP. You can use network security groups, or NSGs, for both models to enhance security. NSGs manage inbound and outbound traffic through network adapters, or VMs, within a subnet. Its rules include name, direction, priority, access, source or destination IP address, port range, and protocol. For IP address categories, custom rules can use default tags like Internet, Virtual Network, and Azure Load Balancer. There are certain limitations while implementing NSGs. You can create 100 NSGs per region per subscription and raise this limit to 400 by contacting Azure support. You can apply only one NSG to one VM, subnet, or network adapter. By default, you can have up to 200 rules in a single NSG and raise this limit to 500 by contacting Azure support. You can apply an NSG to multiple resources. To evaluate traffic in NSGs, for inbound traffic, the subnet NSG evaluates traffic first, and then VM NSG evaluates any traffic allowed through subnet NSG. On the other hand, it is reversed for outbound traffic. Here, VM NSG evaluates traffic first, then subnet NSG evaluates any traffic allowed through VM NSG. What else? Application security groups, also called ASGs, enable you to configure network security as a natural extension of an application structure and apply your security policy at scale without manually maintaining explicit IP addresses. The image displays an example to understand the role of ASGs. ASGs have certain limitations, such as restricting the number of ASGs you can have in a subscription, specifying one ASG, but cannot select multiple ASGs in the source or destination. All network interfaces assigned to an ASG must exit in the same virtual network in which the first network interface will assign to the ASG. Now, let's understand about the service endpoints. Service endpoints get commonly used for VMs accessing storage. The storage account restricts access to the VM's private IP address. Service endpoints change service traffic to use private addresses in the virtual network as source IP addresses when the Azure service gets accessed from the virtual network. With the service endpoints, you can improve the security of Azure service resources, bring the optimal routing for Azure service traffic from your virtual network, take service traffic directly from the virtual network to the service on the Microsoft Azure backbone network, set it up with less management overhead. Let's now explore the scenarios in which the service endpoints would provide benefits. First, the service endpoints peers or connects with multiple virtual networks. Second, they relate to filtering outbound traffic from a virtual network to Azure services. Third, they secure Azure resources to services to deploy directly into virtual networks. And the fourth is that the service endpoints can benefit its disk traffic from an Azure VM. What is a private endpoint? A private endpoint is a network interface for an Azure service within a virtual network. Setting one up for your storage account forms a secure connection between your virtual network clients and your storage. That's not all. You can create your own Azure Private Link service in your virtual network and deliver it to your customers. Azure Private Link offers a consistent way of setting up and usage, which is applicable for the Azure Platform as a Service or PaaS, customer-owned and shared partner services. Azure Private Links enable access services on the Azure platform privately, relate on-premises and peered networks, protect against data leakage, and reach globally by connecting privately to services running in other regions. To deploy a private link, you can request a connection to the service provider to consume the service. It works on the approval call flow model. That's it. Let's summarize. In this video, you learned about network security and defense strategy, NSG's implementation, and creating ASGs. Then you learned about service endpoints and private endpoints. Hello, and welcome to the video, Implement Application Security in Azure. In this video, you'll refresh your knowledge on the Application Gateway, Web App Firewall, WAF, Azure Front Door, and ExpressRoute. Let's begin with Azure Application Gateway. The Azure Application Gateway is an application delivery controller encompassing functionalities like Hypertext Transfer Protocol, HTTP, load balancing, traffic management, and WAF capabilities. Additionally, it extends support for the Secure Sockets Layer, also called SSL, to encrypt your data and enhance the security of web applications. Here are the features offered by the Application Gateway: SSL support, auto-scaling capabilities, zone redundancy, static virtual internet protocol (VIP) support, web application firewall (WAF) functionality, ingress controller for Azure Kubernetes service, support for hosting multiple sites, redirection capabilities, handling of WebSocket and HTTP/2 traffic, draining functionality for seamless maintenance, ability to rewrite HTTP headers, and sizing options for tailored configurations. The Azure Application Gateway has two versions and functions as an application-level gateway for your servers. To set up servers in the Application Gateway settings, version 1 contains the Application Gateway's public key, which you can use to secure and authenticate the messages sent by your servers. Application Gateway version 2 employs a distinct authentication approach, where the certificate authority verifies your server's SSL certificate in the backend pool. Now, let's look at the component of the Application Gateways. The most significant components of the Application Gateway are the front-end IP addresses, listener, and backend pool. A front-end IP address is the IP address associated with an application gateway. You can configure an application gateway to have a public IP address, a private IP address, or both. Listeners are the gatekeepers of incoming requests, which scrutinize the requests based on specific details such as protocol, port, hostname, and IP address. These listeners are of two types, basic and multi-site. SSL enhances the security architecture when configuring the listener in the application gateway, providing a cryptographically secured communication channel. The backend pools encompass a range of components including network interfaces, NICs, virtual machine VM scale sets, public or internal IP addresses, and multi-tenant backends. Additionally, it incorporates diverse elements such as single VMs, collections of VMs, scale sets, physical computer IP addresses, whether on-premises or remote, and services delivered through Azure App Service. That's not all. WAF is a cloud-native security platform designed to safeguard web applications by acting as an application delivery controller, ADC. Usually, the WAF is installed on a web server to examine incoming requests and prevent access to those that do not comply with its defined rules. Deployment options include integrating the WAF service within the Azure cloud or using it within your data center. WAF service has primary features such as monitoring, customization, and policy and rules. WAF policies are associated with an application gateway for a global policy, a listener for a per-site policy, or a path-based rule for a per-uniform resource identifier, URI policy. With Azure Front Door, you can enhance the routing of worldwide web traffic to achieve optimal performance and ensure immediate global failover for maximum availability. Additionally, it empowers you to turn your global multi-region consumer and enterprise applications into resilient, high-performance, personalized modern applications, APIs, and content accessible to a vast global audience through Azure. Azure Front Door offers numerous functionalities, including the acceleration of application performance, ensuring high application availability through intelligent health monitoring, URL-based routing, hosting multiple sites, session affinity, transport layer security, TLS termination, managing custom domains and certificates, enhancing application layer security, URL redirection and rewriting, and providing support for various protocols. What is ExpressRoute? ExpressRoute creates a dedicated and secure connection between your wide area network, WAN, and Microsoft services, such as Azure, bypassing the need for the public internet. It allows you to set up a site-to-site VPN as a reliable backup route for ExpressRoute or connect sites external to your network, but still accessible through ExpressRoute. How do you encrypt the ExpressRoute? Azure Virtual WAN establishes a security VPN connection using the Internet Protocol Security IPsec and Internet Key Exchange IKE to connect your on-premises network with Azure. This connection accomplishes via private peering on an Azure ExpressRoute circuit. ExpressRoute supports some encryption technologies such as point-to-point encryption, media access control security MACsec, and end-to-end encryption IPsec and MACsec. ExpressRoute Direct allows you to connect directly to Microsoft's global network at peering locations strategically distributed across the world. ExpressRoute Direct has several features. It prioritizes substantial data ingestion into services such as storage and Cosmos DB. It ensures physical isolation for various industries and enables precise control over circuit distribution tailored to specific business units. To summarize, the video covered a detailed explanation of encrypting, configuring, and implementing application gateways. Additionally, it includes sections on deploying WAF, configuring Azure Front Door, and reviewing ExpressRoute. Hello, and welcome to the video Configure and Manage Host and Container Security. In this video, you'll refresh your knowledge of Privileged Access Workstations, or PAW, Virtual Machine or VM templates, containers, serverless compute, and Azure App Service. Let's begin with Azure Security Management and Threat Defense Practices. Several practices manage security and threats in Azure, such as securing remote control of VMs, protecting against denial of service, also called DOS, securing connections from VMs to the Microsoft Azure Structured Query Language SQL database. What does the endpoint do? The endpoint helps to protect the assets that are the last touch point of the network it is connected to. Microsoft Defender for Endpoint is an enterprise endpoint security platform designed to help enterprise networks prevent, detect, investigate, and respond to advanced threats. To build robust cloud services for Windows 10, you can use several technologies, such as endpoint behavioral sensors, cloud security analytics, and threat intelligence. The key capabilities of Microsoft Defender for Endpoint are built-in core vulnerability management, attack surface reduction, next-generation protection, endpoint detection and response, automatic investigation and remediation, Microsoft Secure Score for devices, and Microsoft Threat Experts. Next, what is Privileged Access Workstation, or PAW? PAW is a highly secure, hardened workstation for sensitive accounts and tasks. It protects against internet attacks and threats by keeping sensitive activities separate from regular workstations. The PAW security controls are focused on mitigating high-impact and high-probability risks of compromise. Such risks and attacks include internet attacks, usability risk, environment risk, supply chain tampering, and possibility of physical attacks. What is a virtual machine or VM template? A VM template is a master copy of a VM that usually includes the guest OS, a set of applications, and a specific VM configuration. These templates are useful to deploy multiple VMs and ensure they are consistent and standardized. The VM template design depends on the user. To deploy a particular solution, you create a master template that links all the required templates. The Remote Desktop Protocol, or RDP, is the most common way to connect to a Windows-based VM running in Azure. PuTTY Secure Shell SSH Terminal is the common tool to connect Linux-based VMs. Azure Resource Manager, or ARM, is an Azure subscription, deployment, and management service. It provides a consistent management layer that allows you to create, update, and delete resources in your Azure subscription. A resource provider, resource manager template, and declarative syntax are key terms for accessing ARM. That's not all. Azure Update Management is a service included as part of your Azure subscription. This service helps you to assess your update status across your environment and manage your Windows and Linux server updates from a single location for both your on-premises and Azure environments. The advantages of the Azure Update Management solution are no agents or additional configurations within the VM, run updates without logging into the VM, list missing updates and provide information about failed deployments, and use natively onboard machines in multiple subscriptions. Azure Disk Encryption for Windows VMs helps protect data to meet your organizational security and compliance commitments. It uses the Windows BitLocker feature to provide volume encryption for the OS and data disks for Azure VMs and is integrated with Azure Key Vault to help you control and manage the disk encryption keys and secrets. Azure Security Benchmark, also called ASB, is part of a set of holistic security guidance that includes some of the well-known security benchmarks, Cloud Adoption Framework, Azure Well-Architected Framework, Microsoft Security Best Practices, and Microsoft Cybersecurity Reference Architectures. ASB was enhanced to the Microsoft Cloud Security Benchmark, or MCSB, to fulfill the requirement of reconciling security controls across multiple cloud platforms and reviewing the Azure security guidance and principles. What else? A container is a self-contained and lightweight environment that allows you to run an application on the host OS in isolation. To interact with containers, Docker access is required. Isolation, OS, fault tolerance, and networking are the features of the container. What is Azure Container Instances, or ACI? ACI is a platform as a service, or PaaS, operating in isolated containers, including simple applications, task automation, and building jobs. ACI has several features in Azure. Facilitates rapid startup, eliminates the need for VMs, provides direct internet exposure, assures isolation, customizes CPU cores and memory, schedules Linux and Windows with the same API, schedules multi-container groups, and facilitates combination container. You can also have Microsoft security recommendations for managing images and secrets for ACI, which include use a private registry, monitor and scan container images, protect credentials. Next, let's look at the considerations for ACI. These considerations are vulnerability, container platform image, activity, and privilege. Now, what is Azure Container Registry, or ACR? ACR is a service that stores and distributes container images. Do you know about the features of ACR? Let's look at them. These are integrated authentication, geo-replication supporting global distribution, and reliability for network-close deployments, virtual network and firewall configuration, and tag locking. ACR supports transport layer security, or TLS, to secure client connections and transfer images over Hypertext Transfer Protocol Secure, HTTPS. ACR offers multiple authentication methods such as security, granular access control, integration with other Azure services, ease of use and management, and support for various scenarios. That's not all. What is serverless computing? Serverless computing is a cloud-hosted execution environment that runs your code but abstracts the management and existence of servers away from you. In serverless computing, you can configure your apps to respond to events. There are different components of serverless computing: Azure Functions, Azure Logic Apps, Azure Cosmos DB, Azure Event Grid, and Azure API Management. Azure App Services is a fully managed PaaS model for developers. Azure handles all the infrastructure maintenance such as OS updates, patching, server hardware, and network resources. While selecting the Azure Service Plan, you should look at certain parameters such as location, pricing tiers, share resources, and OS. App Service Environment, also called ASE, is a premium feature of Azure App Service that provides a fully isolated and dedicated environment for securely running your applications at a large scale. Let's summarize. In this recap video, first you learned about Azure Security Management and Threat Defense Practices, Endpoint Protection, and PAW. Then you learned about Update Management Solutions, ASB, and containers including ACI and ACR. You also learned about serverless computing and Azure App Service Environment. Hello, and welcome to the video, Manage Access to Azure Kubernetes Service. In this video, you'll learn about Kubernetes and its Azure services. You'll also learn to configure, secure, manage, and deploy Azure Kubernetes services, also called AKS, in detail. Let's begin with containerized workloads. Containerized workload is the process of organizing, adding, removing, or updating a significant number of containers. Container orchestrations is a mechanism that automates the deployment and management of containerized applications. For example, the orchestrator can adaptively adjust the number of deployed instances of the managed app in response to environmental changes. Kubernetes is a portable, extensible open source platform for managing and orchestrating containerized workloads. It simplifies complex container management tasks and provides declarative configuration to produce containers in different computing environments. What are the benefits of Kubernetes? It provides self-healing of containers, dynamic scaling, and automates update rolling and container rollbacks. There are several options to manage the deployment of pods in a Kubernetes cluster when using kube control. These are pod templates, replication controllers, replica sets, and deployments. Kubernetes offers several installable networking options to configure networking, such as Antria, Cisco Application-Centric Infrastructure, Cisco ACI, Cilium, Flannel, KubeNet, VMware NSXT, and WeaveNet. A Kubernetes service is a Kubernetes object that provides stable networking for pods. It enables communication between nodes, pods, and users of your app, both internal and external to the cluster. As an orchestration platform, Kubernetes supports several challenges, including dealing with failed containers, storage allocation, network configuration, and management of app secrets. You want to use Kubernetes when your company does the following: develops apps as microservices, develops apps as cloud-native applications, deploys microservices by using containers, updates containers at scale, requires centralized container networking and storage management. The Kubernetes cluster architecture has two components, the control plane and nodes. The control plane provides core Kubernetes services and orchestration for application workloads. It caters to the services such as API Server, Backing Store, Scheduler, Controller Manager, and Cloud Controller Manager. While nodes run your application workloads and provide services such as Kubelet, kubeproxy, and Container Runtime. In Kubernetes, the initial step involves defining permissions in the form of roles before assigning them. Roles grant access to particular namespaces within the Kubernetes environment. Nevertheless, when unrestricted access across all namespaces is required, cluster roles are helpful. How does Kubernetes simplify the network configuration for application workloads? Kubernetes employs services to unite pods and logically establish network connectivity. 4 service types are available for crafting network configurations: cluster IP, node port, load balancer, and external name. What is AKS? AKS provides a managed service that reduces deployment complexity and core management tasks, including coordinating upgrades. You can build AKS on open source such as the AKS engine. The features of AKS are fully managed, public IP and FQDN private IT option, accessed with role-based access control, RBAC, or Azure Active Directory, Azure AD. Deployment of containers, dynamic scale containers, automation of rolling updates and rollbacks of containers, management of storage, network traffic, and sensitive information. Now, let's look at the diagram to understand data storage and management in AKS. AKS cluster includes a persistent volume. The volume uses Azure Managed Disks as premium storage and Azure Files as standard. A volume represents a way to store, retrieve, and persist data across pods and through the application lifecycle. Traditional volumes to store and retrieve data get created as Kubernetes resources backed by Azure Storage. These data volumes can use Azure Disks or Azure Files. Azure Disks can be used to create a Kubernetes data disk resource. Disks can use Azure Premium Storage backed by high-performance solid-state drives, SSDs, or Azure Standard Storage backed by regular hard disk drives, or HDDs. To access multiple pods simultaneously, you must opt for Azure Files. Azure Files can mount a Server Message Block 3.0 or SMB 3.0, share backed by an Azure Storage account to pods. Azure Files lets you share data across multiple nodes and pods. It can use Azure Standard Storage supported by regular HDDs or Azure Premium Storage, backed by high-performance SSDs. In AKS, you can create two initial storage classes, Default and Managed Premium. The Default Storage class uses Azure Standard Storage, while the Managed Premium Storage class uses Azure Premium Storage to create a managed disk. What does Microsoft say about secure authentication to AKS with Azure Active Directory or Azure AD? Well, there are different ways to authenticate with and secure Kubernetes clusters. With Azure Role-Based Access Controls or Azure RBAC, administrators can grant users or groups access to only the necessary resources. With AKS, they can also enhance the security and permission structure using Azure AD. Azure AD's robust security features, including Azure RBAC, multifactor authentication, conditional access policies, and identity protection, significantly enhance its AKS cluster's security posture. When users attempt to access the AKS cluster, it prompts them to sign in with their Azure AD credentials. In the Azure ecosystem, there are two fundamental Azure RBAC mechanisms: Kubernetes RBAC for managing AKS clusters, and Azure RBAC for managing resources within Azure subscriptions. Secrets inject sensitive data like keys and access credentials into pod definitions or deployment. You can create a secret using Kubernetes API instead of placing this sensitive data directly in a defined pod or container image, then request it when ready for pod definition or deployment. Let's summarize. In this video, you learned what Kubernetes is and its challenges and benefits. Then you reviewed configuration, management, storage, deployment, and security concepts in Azure Kubernetes Service.
Azure Database Security encompasses all security measures Microsoft Azure takes to ensure that its customer data is kept safe and secure from unauthorized access, data breaches, and other malicious activities. Welcome to the video overview of database security. When we talk about Azure Database Security, it involves several concepts, including, but not limited to, firewalls, virtual network service endpoints, authentication, authorization, data encryption, threat detection, and auditing. Azure SQL Database, for instance, uses firewall at the server and database levels to protect the data. The server-level firewall rule allows traffic from specified IP addresses, while the database-level firewall allows access to specific databases. The combination of these two provides an added layer of security. Similarly, Azure Cosmos DB uses an IP firewall to control network access. Virtual network, VNet, service endpoints extend your VNet private address space and protect the identity of your VNet to Azure service resources, ensuring that only traffic from your VNet can access the databases. Azure supports a robust set of technologies for authenticating users who attempt to access Azure databases, including using Azure Active Directory for identity management and SQL authentication, which involves username and password combinations. Authorization in Azure databases is handled through RBAC, role-based access control, which provides fine-grained access management to Azure resources. It allows you to grant users the appropriate amount of access based on their role within your organization. Azure provides several encryption options to secure data at rest, in motion, and during processing. Transparent Data Encryption, TDE, encrypts SQL Server, Azure SQL Database, and Azure Synapse Analytics data files, preventing unauthorized access from the storage layer. Always encrypted feature in SQL Server and Azure SQL Database helps to protect sensitive data such as credit card numbers or national identification numbers in transit and while in memory. Microsoft Defender for Identity, formerly called Azure's Advanced Threat Protection, ATP, for databases, offers comprehensive monitoring and threat detection. It can identify unusual and potentially harmful attempts to access or exploit databases and will generate alerts for suspicious activities like SQL injection attacks, access from unique locations, and more. Auditing is another vital aspect of Azure database security. It tracks database events and writes them to an audit log in your Azure Storage account, Log Analytics workspace, or Event Hubs. Auditing can help you maintain regulatory compliance, understand database activity, and gain insight into discrepancies and anomalies that could indicate business concerns or suspected security violations. Apart from these, Azure offers several other security measures like data masking, which obscures sensitive data in the database from non-privileged users. Private Link allows access to your Azure SQL database servers over a private endpoint in your virtual network, ensuring secure connectivity. Azure continuously updates its services with the latest patches to ensure a safe database environment without user intervention. Furthermore, Microsoft Azure regularly undergoes several independent third-party audits to receive certifications, ensuring it meets global and regional compliance requirements. Imagine you are on an online vendor's IT team handling sensitive customer data, including phone numbers, home addresses, and credit card details. At the same time, you also manage critical business data such as financial records and proprietary intellectual property. The implications of this data falling into the wrong hands through malicious access or exposure are grave. Such an event can jeopardize business operations, trigger financial penalties, and shatter customers' trust in the brand. Therefore, a significant part of your responsibility is to ensure this data stored in databases is as secure as possible. Now imagine you are an attacker trying to breach a system. A system with a single layer of protection might be easily compromised. However, a system with multiple layers, where each layer is designed to protect the one beyond it, is significantly harder to infiltrate. This method is the principle of defense in depth, a strategy that employs a layered approach to slow down an attack aimed at acquiring unauthorized access to data. With its built-in security capabilities, Azure SQL Database enables you to adopt this defense-in-depth strategy. The service includes tools for configuring database firewalls, managing secure access, and encrypting communication between the database and applications. It even has sophisticated measures like threat detection and proactive security alerts through services like Microsoft Defender for Cloud for SQL. Let's review. In this video, you explored the multifaceted security features offered by Azure for its databases. We discussed firewalls and virtual network service endpoints, authentication and authorization, data encryption, threat detection, auditing, and other security measures. We also touched on the importance of regular updates and staying informed about continuous improvements in Azure to maintain a robust and secure database environment.
Hello, and welcome to the video, Secure Applications in the Microsoft Identity Platform. In this video, you will refresh your knowledge about the Microsoft Identity Platform, registering web applications, also called apps, and daemon and non-interactive applications. Let's recap what you have learned. The defense in-depth approach plays a pivotal role in application security. It's all about protecting your data from unauthorized access. The idea is to have layers of security throughout the process, from designing and developing to deploying your applications. So these security measures are integrated into the platforms and technologies you use. Regarding security assurance, we covered 5 important components: application code, application services, application hosting platforms, modern applications, and containers. The Azure Active Directory, also known as the Azure AD, is not just any ordinary thing. It's actually a developer platform that's part of the Microsoft Identity Platform. It offers an authentication service and handy open-source libraries. Plus, there's application registration and setup via a developer portal. This platform is on top of its game regarding supporting standard business protocols. We're talking about OpenID Connect and OAuth 2.0. These protocols are like the superheroes of secure authentication and authorization process. When it comes to developers and the Microsoft Identity Platform, there are a few things you should know. First off, they've got this fantastic app registration experience. It helps you get your apps up and running hassle-free. Then, you've got these endpoints. They're like gateways that let your apps connect and communicate with the Microsoft Identity Platform. And lastly, the platform supports different identities. It's got your back when it comes to handling various identity types. Next, let us focus on single-page applications, or SPAs. Basically, SPAs are dynamic web apps that run on the client side in your browser and are usually confined to just one web page. You can choose the SPA development style for your web if you want your app to have a slick and interactive user interface, your team is familiar with JavaScript or TypeScript development, you need your app to expose an API for other internal or even public clients. Modern web apps are all about JavaScript and SPA frameworks. These apps are called client-side SPAs, meaning they work their magic in your browser. In the past, these apps connected to protected sites using the implicit OAuth 2.0 route to authenticate and get an access token. Have you heard about the Microsoft Authentication Library? It's also known as MSOL for JavaScript. This library is the most convenient way to use the Microsoft Identity Platform for authentication and to receive access tokens to authorize requests to secured endpoints in SPAs. Head to the Microsoft Azure portal and sign in to get started. Once you're in, find your way to Azure AD. Look for the App Registration section and select it. It's time to create a new registration. Select the New Registration button. You'll be prompted to enter some necessary details, so go ahead and do that, and then just select Register. You've got your SPA all set up and ready to go. Next, from the Manage blade, select Authentication. Select Add a Platform on the newly created application's authentication page. Then, in the Configure Platforms panel that appears, select Single Page Application. Enter the required details in the Configure Single Page Application page and then select Configure. Now you're moving on to register web apps that sign in users and make calls to APIs. You began by creating web applications that call APIs and sign in users. You can create a web app using OAuth 2.0 protocol that needs user authentication and authorization to access restricted resources such as APIs or data. Over the implicit grant flow, the preferred code grant flow is OAuth 2.0. Then you discovered how to set up an application on the Azure interface, including registration. The client secret plays a pivotal role in setting up an application on the Azure interface, including the all-important registration process. It's vital to remember that OAuth configuration depends on the web app's runtime, which may be Java, Python, .NET Core, or PHP. You created server-side web apps that sign in users and call APIs through the Microsoft Azure portal. Do you know that configuring authentication happens in two different types of apps? Daemon and non-interactive. The applications that run without user interaction are called daemon apps. The daemon app can only request application permissions to APIs, not delegated permissions. In contrast, non-interactive applications act on users' behalf but need elevated privileges that a user doesn't have. It accesses a web API or resource with its identity, not the user's. You also learn to register a daemon app, grant permissions, and grant admin consent for Azure AD. When registering your app in Azure AD, you can create a Secure Sockets Layer, or SSL, a certificate for public and private key pairs. With these keys in place, your service or daemon app can sign a special kind of token called a JSON Web Token, or JWT, and pass it over to the token endpoint. Administrators can also use a client secret rather than a certificate. Let's summarize what you covered in this video. You explored how to secure applications in the Microsoft Identity Platform. You learned about the Microsoft Identity Platform, registering web apps, and daemon and non-interactive apps. Hello, and welcome to the video Explore Azure Active Directory Authentication and Application Registration. In this video, you'll refresh your knowledge about Azure Active Directory, also called Azure AD and App Registrations. Let's recap what you have learned. Azure AD simplifies the authentication process for developers. By using industry-standard protocols such as OAuth 2.0 and OpenID Connect, developers can authorize their applications to access data from other applications. It also provides a secure and reliable way to authenticate users and verify their identities. The Microsoft Identity Platform is an evolution of Azure Active Directory. It allows developers to build applications that sign in users and access resources in external Microsoft applications, other software as a service or SaaS applications, and internal resources. The Microsoft Identity Platform implements the OAuth 2.0 authorization protocol. This protocol is a method by which a third-party application can access web-hosted resources on behalf of a user. Depending on the application, developers can leverage one type of permission. There are 3 types of Microsoft permissions for developers. When a user is signed into the application uses delegated permissions. When no user is signed into the application uses application permission. Effective permissions are an intersection of delegated and application permissions. That is, an intersection between what the app is allowed to do and what the user is allowed to do. Consent is the process of a user granting authorization to an application to access protected resources on their behalf. In an OpenID Connect or OAuth 2.0 authorization request, an application can request the permissions it needs. If users get advanced permissions to access their application, the consent message will prompt on their screen. Any application that outsources authentication to Azure Active Directory or Azure AD must be registered in a directory. This step involves giving Azure AD information about your application. Now let us explore some Azure application scenarios for different applications. There are 2 representations of applications in Azure AD, the application object and the service principal. The application object is the global representation of your application for use across all tenants. The service principal is the local representation for use with a specific tenant. Azure AD supports 5 primary application scenarios: web browser to web application, single-page application, native application to web API, web application to web API, and daemon or server application to web API. The Microsoft Identity Platform in Azure Active Directory performs identity and access management, frequently referred to as IAM, only for registered applications. Registering a client application, such as a web or mobile app, or a web API that backs a client app, establishes a trust relationship between the application and the identity provider. Here are the steps you follow to register an application using app registrations. 1. Log in to the Azure portal and navigate to the Azure Active Directory. 2. Within the Manage blade, select App Registrations. 3. Click on New Registration. 4. Fill in all the required details for the application. Finally, select Register to complete the registration process. Registering an application with a Redirect Uniform Resource Identifier, commonly known as a Redirect URI, is a crucial concept. This Redirect URI is a fundamental aspect of the application registration process in the Azure Active Directory. When registering an app with Azure, you need to specify the Redirect URI. It serves as the callback URL where Azure AD will redirect the user after they successfully authenticate and authorize the app. This step is essential for securely enabling the application to obtain the required access tokens. By understanding and correctly setting up the Redirect URI, you ensure that your app can seamlessly handle authentication and authorization processes, allowing it to interact with other applications and services efficiently and securely. To allow users to use the same authentication they use for Microsoft 365 for your apps, you must begin by creating an Azure AD tenant using the Azure portal. Next, register your application in Azure AD to establish a connection. Finally, configure the app registration settings to ensure smooth authentication. To help developers use OpenID Connect in their applications, Microsoft provides middleware to facilitate this communication. Let's summarize what you covered in this video. You explored how to secure applications on the Microsoft Identity Platform. You learned about Azure Active Directory and app registrations. Hello, and welcome to the video Configure Microsoft Graph Permissions. In this video, you will learn about Microsoft Graph Services, types of Microsoft Graph permissions, and how to configure Microsoft Graph permissions using app registrations. Let's dive deep into this. Microsoft Graph provides data access across Microsoft 365 services. Custom applications can use the Microsoft Graph API to connect to data and enhance organizational productivity. The app may obtain the necessary data and streamline the overall development process by using Microsoft Graph, which offers a single endpoint. What is Microsoft Graph Security API? It is the intermediary service that provides a single programmatic interface to connect multiple Microsoft Graph security providers. Microsoft Graph Security API offers the solution if you wish to integrate custom apps with data saved across Microsoft 365 services and increase productivity in your business. For example, the sales application helps assign a customer to a salesperson and offers a thorough history of their interactions. Using the application, a salesperson can view the following: messages sent, chat and email, meetings attended, notes, key contacts, related files. Let's look at the benefits of employing Microsoft Graph. It helps to get a history of interactions between salespeople and customers, sees messages that a salesperson sent to a customer, Microsoft Teams chat or email, access information about prior meetings and notes, identify key people within the organization who can help with customer questions, review files related to a customer. The Microsoft Graph Representational State Transfer APIs, also called REST APIs, and client libraries allow you to access many kinds of data and intelligence. Such data are users and groups, Teams data, tasks, files, mail, meetings and calendars, organizational charts. It is important to note that Microsoft Graph is specifically designed to access Microsoft 365 data. It is unrelated to graph technologies like graph databases or GraphQL. Microsoft Graph services provide an integrated experience for users. For example, you can use Microsoft Graph services to make it effortless for users to do real-time collaboration and share documents using SharePoint and OneDrive integration. Microsoft Graph services are centered on users and groups. A user's data is the core of Microsoft 365 Cloud services. Microsoft Graph services can access the following information for a user: mail, conversations, file, events, devices, security, tasks, groups. While groups are the base environment for a user's collaboration and teamwork in Microsoft 365, Microsoft Graph can access the following information for a group: mail, conversations, files, events, devices, security, tasks, group user. Let's look at 3 areas where Microsoft Graph services can help you integrate Microsoft 365 data into your apps. These 3 areas are identity and access management, productivity and collaboration, and people and workplace intelligence. You can make Microsoft Graph REST API requests using the free open-source Microsoft Graph Explorer application without any installation or setup. Let's take a quick overview of the Graph Explorer tool. 1. You can access Graph Explorer from this site. 2. An HTTP verb drop-down list helps you modify your HTTP requests, such as get, post, put, patch, and delete. 3. A version drop-down list helps you change the API version in the query to version 1.0 or beta. 4. A query editor lets you modify the query and see the results by selecting the Run Query button. 5. Sample Graph API queries are available to search through and test. 6. A selected query will automatically run and show the results in Graph Explorer. 7. A link to related API documentation is next to each sample query. Let's look at the steps to run a query to view the list of all applications. 1. First, select Applications in Microsoft Graph Explorer. 2. Select Get List All Applications with Count. Then select Run Query. 3. You may get an error if you do not have sufficient privileges. To provide sufficient privileges, select Modify Permissions. 4. Select the required consent. 5. Select Accept. 6. Select Run Query and view the result. That's not all. There are 2 types of Microsoft Graph permissions. The first is delegated permissions, where the apps can use these permissions when you have a signed-in user. The second is application permissions, where apps can use these permissions when you don't have signed-in users. Effective permission is required when you request a Microsoft Graph. It is an intersection of delegated and application permissions. The effective permissions are visible on the Configured Permissions page. To configure Microsoft Graph permissions, log into the Azure portal and search for Azure Active Directory. Then select App Registrations and choose an application within the Owned Application tab. Next, select API Permissions and choose Add a Permission. Now, select Microsoft Graph and select Delegated or Application Permission to add them. Let's summarize. In this video, you learned about Microsoft Graph and its API. Then you learned about the Microsoft Graph services, types of permissions in Microsoft Graph, and how to configure Microsoft Graph permissions. Hello, and welcome to the video Configure Managed Identities and Web App Certificates. In this video, you will learn about managed identities and how to enable and configure them. Then you will learn about Web App Certificates and its configuration and deployment. Let's begin by understanding the managed identities. Applications can connect to resources that accept Azure Active Directory or Azure AD authentication by using managed identities, which give users an automatically managed identity in Azure AD. Without handling credentials, applications can get Azure AD tokens using managed identities. There are several terminologies for managed identities, like Client ID, Principal ID, and Azure Instance Metadata Service, also called IMDS. Managed identities are of 2 types: system-assigned managed identity that is enabled directly on an Azure resource, and the user-assigned managed identity that requires an active subscription to create a trusted identity via a creative process. Next, let's look at the detailed flow of how the 2 managed identities work with Azure VMs. Step 1 is to enable managed identity for Azure VM. Step 2 is to create a new managed identity service principal in Azure AD. Step 3 is to update IMDS with the new managed identity. Step 4 is to create the managed identity access to Azure resources or services via Azure Role-Based Access Control or Azure RBAC. Step 5 is to request a token from the local endpoint. Step 6 is to request a token from Azure AD. And Step 7 is to call Azure Service with Azure AD token. Let's look at how to enable managed identities. To enable system-assigned managed identities, scroll the left navigation pane on the App Services page and select Identity. Within the System Assigned tab, turn the status to On and select Save. To enable User-Assigned Managed Identity, you must create a User-Assigned Identity resource. On the App Service page within Identity page, select User-Assigned tab, select Add. Search for the identity you created earlier and select it. Select Add. Let's look at some best practice recommendations for managed identities. Resources that support managed identities can have both a system-assigned identity and 1 or more user-assigned identities. User-assigned managed identity is recommended for rapid creation of resources, replicated resources, compliance, and access before deployment. Using user-assigned identities can reduce administration by reducing the numbers of role assignments. System-assigned identity is recommended for audit logging and permission lifecycle management. An app can get tokens for Azure resources protected by Azure AD, including Azure Storage, Azure Key Vault, and Azure Structured Query Language or SQL databases to connect to Azure services in the app code using its managed identity. These tokens reflect the application, not a particular user accessing the resource. That's not all. Web App Certificates, Secure Socket Layer, SSL, or Transport Layer Security, TLS certificates, which encrypt the data exchange between a web application and its users, enable secure communication over the Internet. These certificates offer an authentication mechanism that confirms the website or service's legitimacy, ensuring that users connect to the intended and legitimate business. There are several options to obtain certificates for web app services. Create a free web app service certificate. Purchase a web app service certificate. Import a certificate from Azure Key Vault. Upload a private certificate. And upload a public certificate. App Service is compatible with Web App Service and the free Web App Service Managed certificates. You must follow certain requirements to import or upload a private certificate to Web App Service, such as it must be exported as a password-protected PFX file format, encrypted triple data export service, also called triple DES. It must have a private key that is at least 2048 bits long. And it must contain all intermediate certificates and the root certificate in the certificate chain. Next, let's explore the pricing tier for web app certificates. To create custom transport layer security or secure socket layer, TLS or SSL, bindings or enable client certificates, your app service plan must be in the basic, standard, premium, or isolated tier. You must check your app service plan to ensure it's supported to the pricing tier. To access web app certificates, log into the Azure portal and search for the app services. On the App Service page, select your web app's name, and in the left menu for your web app, under the settings, select Scale Up, App Service Plan. Ensure your web app isn't in the F1 or D1 tier, which doesn't support custom TLS or SSL. The free App Service Managed certificate is a complete solution for protecting your unique domain name system, or DNS name, in App Service. The TLS or SSL server certificate for App Service is completely managed and is automatically renewed every 6 months, with 45-day intervals before expiration. However, managed certificates have some restrictions. It doesn't support wildcard certificates. It doesn't support usage as a client certificate by using certificate thumbprint, which is planned for deprecation and removal. It doesn't support private DNS. It doesn't get export. It doesn't support in an app service environment, or ASE. It supports alphanumeric characters, dashes, and periods. To create an app service certificate, select Certificates in the left navigation pane on the App Services page. Now, in the Manage Certificates tab, select Add. Then select Custom Domain from the drop-down list. And select Add. You can create only one certificate for each supported custom domain. To deploy the web app certificate, you must buy a custom domain, for example, GoDaddy. Before purchasing a web app certificate, you should follow this checklist. Azure handles the purchase process from GoDaddy. It performs certificates domain verification. It maintains the certificate in Azure Key Vault. It manages certificate renewal. And it synchronizes with certificate with the imported copies in App Service apps. To import a certificate, on the App Service page, select Certificates. Now, select Bring Your Own Certificate tab and select Add. An Add Private Key Certificate pane appears. Select the source of certificate from the drop-down list. You have 3 options for the certificate source: Import App Service Certificate, Upload Certificate, .pfx, Import from Key Vault, and select Add. Let's summarize. In this video, you learned about managed identities in detail. Then you learned about web app certificates and how to purchase, create, and import them.
Hello, and welcome to the recap of Course 5, Secure Your Data at Rest. In this video, Secure Azure Storage for Access Control, you will get a recap of the access control mechanisms you can use to protect your data and maintain regulatory compliance. Azure Storage is a cloud-based service in Microsoft Azure designed for storing and managing data. Azure stores data in data centers worldwide. The data stored in these data centers is subject to the laws of the country or region in which it is located. This concept is known as data sovereignty. Azure implements data sovereignty via Azure paired regions, providing multiple benefits such as physical isolation, platform-provided replication, region recovery order, sequential updates, and data residency. You can control access to data in Azure Storage using shared keys, shared access signatures, also called SAS, Azure Active Directory, also called Azure AD, and Azure AD Domain Services, also called Azure AD DS. You can also provide public access to Azure Storage. Shared keys grant root-level access to the storage account. You can use shared keys to give the user the highest privilege and control over the entire storage account. SAS allows you more control over the user's access. You can create a token with specific permissions and an expiration time for accessing a resource. With Azure AD, you can use role-based access control, also called RBAC, to grant access to blob and queue resources to users, groups, or applications. Azure AD DS can enable identity-based authorization over server message block in Azure Files. Public access allows you to grant read-only access without sharing your account key or requiring a SAS. Let's dive deeper into shared keys. Shared keys or storage account access keys are automatically generated by Azure when you create a storage account. These keys consist of a primary access key and a secondary access key, which provide equal privileges. You can utilize shared keys for specific administrative tasks requiring full access. However, it is crucial to safeguard access to shared keys. You can disable shared key access when not needed. Avoid hard-coding the keys or saving the keys in plain text. Rotate keys if you think they are compromised. You can use Azure Key Vault to manage your access keys and regularly rotate and regenerate your keys without causing interruption to your applications. The process of replacing existing cryptographic keys with new keys in a secure manner is known as key rollover. Key rollover enhances security by mitigating the risks associated with long-term key usage. You can test a key rollover using the Azure portal to fetch an access key and Azure Storage Explorer to connect to a storage resource using the key. Let's review the details of SAS. You can use query parameters in a SAS token to define the client access. These parameters include SP for signed permission, ST for start time, SE for expiry time, SPR for signed protocol, SV for signed version, SR for the scope of the resource, and SIG for signature. There are three types of SAS: user delegation SAS, service SAS, and account SAS. The most secure SAS is user delegation SAS. Let's see an example of when using SAS would be suitable. You want authenticated users to upload videos directly to Azure Blob Storage without giving them full access to your storage account or exposing the primary keys. A best practice for using SAS is to set the expiration time to the shortest period necessary for the required access. You must also apply the rule of minimum required privileges. We recommend using authentication and authorization methods such as SAS and Azure AD instead of shared keys. SAS and Azure AD offer granular control and enhanced security. You can add additional control over SAS by implementing stored access policies on the server side. They enable the grouping of SAS and provide more fine-grained restrictions for signatures governed by the policy. Let's see an example of when using stored access policies would be suitable. In a document collaboration platform hosted on Azure Blob Storage, multiple users need read and write access to shared documents stored in a container. Instead of creating individual SAS tokens for each user, you can create a stored access policy with appropriate read and write permissions for the container. All users can then obtain SAS tokens tied to this stored policy. There are certain things to remember about a stored access policy. You can have only up to 5 stored access policies for a blob container. Also, the policy takes up to 30 seconds to become active. You cannot specify table entity range restrictions in a stored access policy. You can modify stored access policy parameters, revoke a stored access policy, remove a single access policy, or remove all access policies. Let's summarize what you covered in this video. You completed a review of the access control mechanisms to secure Azure Storage. You learned about data sovereignty, shared keys, SAS, and stored access policies. Hello, and welcome to the video, Configure Authentication and Encryption for Storage Accounts. In this video, you'll recap what you learned about authenticating access to a storage account, securing data at rest, securing data in transit, and controlling how data is accessed and transmitted to and from an Azure storage account. Let's first look at authenticating access to a storage account. You use Azure Active Directory, also called Azure AD, to authenticate access to a storage account. Azure AD security features help your organization improve storage security. You can enable multi-factor authentication for user accounts, providing an extra layer of protection. You can strengthen your security measures by consistently monitoring logs and detecting unusual authentication activities. Azure AD integrates with Azure Monitor and Azure AD audit logs. This integration provides comprehensive auditing capabilities to track and monitor access events, conduct security audits, and investigate security or policy violations, helping meet compliance requirements. With Azure AD, unlike shared keys or shared access signatures, you can use Azure Role-Based Access Control, also called Azure RBAC, to grant permissions to users, groups, or applications within Azure Storage. Typically, storage account authentication using Azure AD is managed by an IT operations team, a dedicated identity and access management team, also called an IAM team, or security officers and administrators who manage the organization's overall infrastructure, security, and access control. Azure RBAC provides several built-in roles for authorizing access to blob data using Azure AD. These include Storage Blob Data Owner, Storage Blob Data Contributor, Storage Blob Data Reader, and Storage Blob Delegator. Now let's review what you learned about securing data at rest. You use Azure Storage Service Encryption to protect your data at rest. Azure Storage Service Encryption ensures your data is secure when stored in the cloud, and it's automatically encrypted using 256-bit Advanced Encryption Standard, also called AES encryption. When encrypting your storage account, you can either rely on Microsoft-managed keys or take control and manage the encryption with your own keys. You have two options if you manage encryption with your own keys: customer-managed keys and customer-provided keys. You use a customer-managed key to encrypt all data and all services in your storage account. You can specify a customer-provided key on blob storage operations. A client making a read or write request against blob storage can include an encryption key in the request to enable granular control over how blob data is encrypted and decrypted. You secure data in Azure Files through Azure Files Authentication and data in Azure Blob using blob data retention policies. You can configure Azure AD authentication for Azure Files by first setting up Azure AD Domain Services, also called Azure ADDS. Then you will enable Azure ADDS authentication for Azure Files and assign Azure RBAC roles to users or groups. You can then sync on-premises AD with Azure AD and mount the Azure file share on your Windows or Linux machine using Azure AD credentials. Blob data retention policies, particularly time-based and legal hold policies, help meet regulatory compliance requirements, ensuring immutable data is kept for a specified period. You can apply these policies at the container level. You can use audit logs to track policy-related actions. Retention policies contribute to data management, governance, cost control, and security. How do you secure data in transit? Azure provides the Secure Transfer Required property to secure data in transit. The Secure Transfer Required property in Azure Storage Services mandates that all data transferred to or from the storage account must be made over a secure HTTPS connection. The Secure Transfer Required property should always be enabled when dealing with sensitive or confidential data. You can enable the Secure Transfer Required property in new and existing storage accounts via the Azure portal and using coding tools including PowerShell and the Azure Command Line Interface, also called CLI. Let's see how to control the data accessed and transmitted to and from an Azure storage account. Securing storage endpoints will help you control how data is accessed and transmitted to and from an Azure storage account. You can secure a storage endpoint by implementing specific configurations in Azure Storage. You can enable the Microsoft .storage option in the service endpoint settings to restrict access to a storage account. Let's summarize what you covered in this video. You completed a review of configuring authentication and encryption for storage accounts. You refreshed your knowledge about authenticating access to a storage account, securing data at rest, securing data in transit, and controlling how data is accessed and transmitted. Hello, and welcome to the video, Configure Database Security and Monitoring. Azure Database Security encompasses all security measures Microsoft Azure takes to ensure that its customer data is kept safe and secure from unauthorized access. data breaches, and other malicious activities. In this video, you will get a recap of what you learned about protecting your Azure Structured Query Language database, also called Azure SQL database. You can protect your Azure SQL database by controlling access, monitoring and auditing the use of data, and using advanced security features. Let's first look at controlling access to your Azure SQL database. You can control access by using authentication, blocking access to your servers using SQL database firewalls, and using virtual network service endpoints, also called VNet service endpoints. SQL database supports two types of authentication: SQL authentication and Azure Active Directory authentication, also called Azure AD authentication. In SQL authentication, the user submits a user account name and associated password to establish a connection. Azure AD authentication leverages Azure AD identities and credentials, allowing users to authenticate using their Azure AD credentials. After a user is authenticated, authorization defines what the user can do within Azure SQL database by controlling granted permissions. Creating user accounts in the master database allows you to grant permissions across databases. Azure SQL database is based on the Microsoft SQL Server database engine. SQL Server provides two security modes for authentication: Windows Authentication Mode and Mixed Mode. You can configure the SQL Server database engine for either mode during setup. You can change the security mode after installation as well. In Windows Authentication Mode, users provide their Windows login credentials to connect to SQL Server or Azure SQL database. This mode relies on the security features of the Windows operating system for user authentication. Mixed Mode, also known as SQL Server and Windows Authentication Mode, allows SQL Server logins, which means using the usernames and passwords managed by SQL Server, and Windows logins to connect to SQL Server. If you choose Windows Authentication Mode, the system administrator login is deactivated, and the installation generates a password. In Mixed Mode, the system administrator login connects to the server solely via SQL Server authentication. Therefore, you must use the alter login command to re-enable the system administrator login and assign a new password. You can also control access to your database by blocking access to your servers using SQL database firewalls. While server-level firewall rules allow you to permit traffic from specified IP addresses, database-level firewall rules allow you to permit access to specific databases. You can also control access to your database using VNet service endpoints. VNet service endpoints extend your VNet private address space and protect the identity of your VNet to Azure services and resources. By using VNet service endpoints, you can ensure that only traffic from your virtual network can access the database. Now, let's look at monitoring and auditing. Monitoring and auditing your Azure SQL database is important to detect anomalies and record activities, providing a detailed log of database actions for security purposes. Auditing allows you to analyze event reports and have pre-configured reports on database activity. You can apply audit policies at the server level or database level. Auditing is turned off by default. To enable auditing, search for and select your server. Then on the left navigation pane under Security, select Auditing. Finally, turn on Enable Azure SQL Auditing using the toggle switch. What are the advanced data security features of Azure that you can use to protect your database? The advanced data security features include data discovery and classification, vulnerability assessment, and advanced threat protection. Data discovery and classification provides capabilities for discovering, classifying, labeling, and protecting the sensitive data in your database. Vulnerability assessment helps you discover, track, and remediate potential database vulnerabilities. Advanced threat protection monitors your database for suspicious activities and provides immediate security alerts on potential vulnerabilities, SQL injection attacks, and anomalous database access patterns. Let's summarize what you covered in this video. You reviewed various ways of protecting your Azure SQL database. You refreshed your knowledge about controlling access to your SQL database by using authentication, blocking access to your servers using SQL database firewalls, and using VNet service endpoints. You also learned about monitoring and auditing the use of data and using the advanced security features of Azure, such as data discovery and classification, vulnerability assessment, and advanced threat protection. Hello, and welcome to the video, Enable Microsoft Defender for Cloud for SQL Databases. In this video, you will get a recap of what you learned about Defender for Cloud, how it works, its features, and when to use it. You will also refresh your knowledge about enabling Defender for SQL. Microsoft Defender for Cloud is a cloud-native application protection platform with a set of security measures and practices designed to protect cloud-based applications from various cyber threats and vulnerabilities. It combines the capabilities of a development security operations solution, a cloud security posture management solution, and a cloud workload protection platform. Defender for Cloud protects and secures your hybrid cloud environments in Azure, Amazon Web Services, Google Cloud Platform, as well as on-premises environments. The overview page of Microsoft Defender for Cloud provides a unified view of the security posture of your hybrid cloud workloads through an interactive dashboard. The page displays statistics such as Azure subscriptions, AWS accounts, GCP projects, assessed resources, active recommendations, and security alerts. The Security Posture section lists the Secure Score. The score is an aggregated score that Defender for Cloud provides based on the continuous assessment of your resources, subscriptions, and organization for security issues. The higher the score, the lower the identified risk level. The Regulatory Compliance section provides insights into your compliance posture based on continuous assessments of your Azure environment. Defender for Cloud analyzes risk factors in your environment according to the security best practices. The Workload Protection section shows the coverage of your connected resources and the alerts based on severity. The Inventory section provides a glance at the total healthy and unhealthy resources. Let's understand the capabilities provided by Defender for Cloud in the areas of securing your cloud applications, improving your security posture, and protecting cloud workloads. We will take an example of a capability you can utilize to secure your cloud applications. The Code Pipeline Insights capability empowers security teams with the ability to protect applications and resources from code to cloud across multiple pipeline environments, including GitHub and Azure DevOps. Which capability can you use to improve your security posture? Centralized Policy Management is a capability that you can utilize to define the security conditions you want to maintain across your environment. The policy translates to recommendations identifying resource configurations that violate your security policy. Now, let's look at an example of a capability you can use to protect cloud workloads. The Protect Cloud Databases capability secures your database estate by detecting and responding to attacks on popular database types in Azure. It provides targeted protection for database engines and data types based on their specific security risks. Defender for Cloud offers plans tailored to specific services and components within cloud environments. Some examples are Defender for Servers, Defender for Storage, Defender for SQL, Defender for Containers, and Defender for Key Vault. By combining different plans and thus their capabilities, you can implement your organization's defense in depth strategy. For example, you might choose Defender for SQL when your organization is focused on discovering and mitigating potential database vulnerabilities. Defender for SQL will also help detect unusual activities that may indicate a threat to your database. You can enable Defender for SQL using Microsoft Defender for Cloud in the Azure portal or programmatically with PowerShell, Azure Policy, Representational State Transfer API, also called REST API, and Azure Command Line Interface, also called Azure CLI. Defender for SQL can be enabled at the subscription or resource levels. To enable Defender for SQL at the subscription level, you will first open Defender for Cloud in the Azure portal. You will then select Environment Settings. You can change the plan settings by turning on the toggle under Status after selecting the relevant subscription. To enable Defender for SQL at the resource level, first sign into your Azure portal and open your server. Then select Microsoft Defender for Cloud under the Security Blade. Finally, select the Enable Microsoft Defender for SQL option. It's a good practice to enable Defender for SQL at the subscription level so that all the new resources are automatically protected. If you want to manage the databases that need to be protected manually, disable them at the subscription level and enable each database you want to protect. Let's summarize. In this video, you refreshed your knowledge of Microsoft Defender for Cloud. You reviewed the various components of the Defender for Cloud dashboard. You understood that Defender for Cloud offers features for securing cloud applications, improving your security posture, and protecting cloud workloads. You learned about Defender for Cloud plans. Finally, you learned about enabling Defender for SQL. Hello, and welcome to the video, Implement Data Masking and Encryption. In this video, you'll get a recap of using data masking and encryption to secure your data in transit, at rest, and on display. Azure uses dynamic data masking, a policy-based security feature that hides the sensitive data in the result set of a query over designated database fields. The data in the database is not changed. Data encryption encodes data so only authorized members can access and decipher it. It helps keep your data safe at rest and in transit. Let's first look at securing data in transit. Azure SQL Database enforces transport layer security network encryption, also called TLS network encryption, for all connections. TLS ensures that your data is encrypted in transit between the database and the client. How is data secured at rest? Azure SQL Database protects your data at rest using transparent data encryption, also called TDE. TDE performs real-time encryption and decryption of the database, associated backups, and transaction log files at rest without requiring changes to the application. By default, TDE is enabled for all newly deployed Azure SQL databases. However, older databases may not have TDE enabled and must be manually enabled. It is also important to check that data encryption has been enabled. Let's see how to configure TDE. Sign into the Azure portal, search for and select your database. On the navigation pane on the left, under Security, select Transparent Data Encryption. Verify that the data encryption toggle is set to on and the encryption status displays encrypted. There are two types of TDE implementation in Azure: Service Managed TDE and Customer Managed TDE. In Service Managed TDE, the default setting in Azure is that a built-in server certificate protects the data encryption key. The built-in server certificate is unique for each server, and the encryption algorithm used is Advanced Encryption Standard 256, also called AES 256. In Customer Managed TDE, the TDE protector that encrypts the data encryption key is a customer-managed asymmetric key stored in a customer-owned and managed Azure Key Vault and never leaves the Key Vault. Let's review securing data on display. Data masking allows you to secure your data on display. Data masking is a technique that helps protect sensitive information when it is displayed to users or applications. It involves applying rules to specific database columns and defining how the data should be masked. Let's understand where to define the dynamic data masking rules. In the Azure portal, search for and select your database. You will find dynamic data masking under the security blade. Let's say you want to add a mask to display only the last 4 digits of the phone number. You can select Add Mask to open the Add Masking Rule dialog box. You can choose the relevant settings and select Add. The dynamic data masking policies involve defining 3 sets of rules. First, dynamic data masking allows certain users to access unmasked data in the SQL query results based on their permissions. Second, a set of rules specifies which fields should be masked and the masking function to be used. Third, a set of methods controls data exposure for different scenarios, ensuring that sensitive information remains hidden from unauthorized users while being visible to those with appropriate access rights. Let's now review the Always Encrypted feature. This feature in Azure SQL Database is designed to protect sensitive data, such as credit card numbers or national identification numbers. Always Encrypted uses 2 types of keys to encrypt data. These are the column master key, also called CMK, and the column encryption key, also called CEK. CEKs are used to encrypt column data, and CMKs are used to protect the CEKs. Always Encrypted offers 2 types of encryption: randomized and deterministic. Randomized encryption encrypts data less predictably, making it more secure. However, it prevents searching, grouping, and indexing and doesn't allow joining on encrypted columns. Deterministic encryption always gives the same result for any plain text. It could allow unauthorized users to guess data about encrypted values by examining patterns in the encrypted column. Let's review the basic steps to deploy an Always Encrypted implementation. The first step is design. You will determine what data should be encrypted and select the correct encryption type. The second step is provisioning CMK and CEK. The third step is setting up key metadata and configuring column encryption. The fourth step is encrypting database columns. The fifth step is developing and modifying applications. The final step is validation and testing. Let's summarize. In this video, you reviewed ways to secure data in transit, at rest, and on display. You learned about using data masking and encryption to secure data. You understood that you could use TLS encryption to secure data in transit, TDE to secure data at rest, and data masking to secure data on display. You also learned about the Always Encrypted feature.
Hello, and welcome to the recap of Course 6, Manage Security Operations. In this video, configure diagnostic logging in Azure Monitor. You'll refresh your knowledge of Azure Monitor, metrics and logs, Azure Monitor alerts, and diagnostic logging. Monitoring involves actively detecting potential security issues and promptly responding to them. Azure Monitor is a comprehensive monitoring solution for collecting, analyzing, and responding to telemetry data from your cloud and on-premises environments. Azure Monitor helps maximize the availability and performance of your applications and services by actively watching over the performance of all your Azure resources and promptly triggering alerts when an issue arises. Monitoring security using Azure Monitor involves 3 steps: creating and customizing alerts, monitoring security logs, and configuring diagnostic logging and log retention. All of the data that Azure Monitor collects fits into one of 2 fundamental data types: metrics or logs. Metrics collects numeric data from monitor resources into a time series database, whereas logs collects and organizes log and performance data from monitored resources. Azure Monitor supports various types of metrics for monitoring and analysis: native metrics, the subsets of native metrics, platform metrics and custom metrics, and Prometheus metrics. Preview. Azure Monitor collects metrics from various sources and consolidates them in the metric database, where they're evaluated together regardless of their source. The data sources include Azure resources, applications, virtual machine VM agents, custom metrics, and Kubernetes clusters. On the other hand, several features of Azure Monitor, such as Azure Monitor Logs, Diagnostic Logs, Azure Monitor for Containers, and Azure Firewall Logs, store their data in logs. Microsoft Defender for Cloud integrates with Azure Monitor to provide centralized logging and monitoring capabilities. The processed events generated by Microsoft Defender for Cloud are published to the activity log, one of the log types available through Azure Monitor. Azure Monitor provides a centralized pipeline for routing monitoring data to a security information and event management (SIEM) tool by first streaming the monitoring data to Azure Event Hubs, from where it can easily be transferred to a partner SIEM tool. There are 5 tiers of monitoring data that can be sent to Azure Event Hubs: application monitoring data, guest OS monitoring data, Azure resource monitoring data, Azure subscription monitoring data, and Azure tenant monitoring data. Next, let's look at Log Analytics, which is a part of Microsoft Azure's overall monitoring solution. Log Analytics is the primary tool in the Azure portal for writing log queries and interactively analyzing the outcomes. Log Analytics workspaces hosted within the Azure environment are the core component of Log Analytics. A Log Analytics workspace collects log data from Azure Monitor and other Azure services, like Microsoft Sentinel and Microsoft Defender for Cloud. So, how is that data retrieved? That's right. Data is retrieved from a Log Analytics workspace through a log query, a read-only request to process data and return results. Log queries are written in Kusto Query Language, KQL, a powerful tool for exploring your data, discovering patterns, identifying anomalies and outliers, and more. A Kusto query consists of a sequence of query statements delimited by a semicolon. There are 2 types of query statements: user query statements and application query statements. So how can you monitor your applications, VMs, and Kubernetes workloads in Azure Monitor? Application Insights, a component of Azure Monitor, is specifically designed for application monitoring. It helps analyze and address issues that affect your application's health and performance, improve your application's development lifecycle, and measure user experience and analyze user behavior. Azure VM Insights helps view the health and performance of your VMs and monitor your VMs at scale across multiple subscriptions and resource groups. Likewise, you can use Azure Container Insights to view the health of your Kubernetes workloads at scale, obtain visibility into memory and processor performance metrics, and access and store container logs for analysis. An effective monitoring solution must proactively respond to critical situations identified in the collected data. That is where alert rules play a crucial role. Acting as vigilant sentinels, alert rules continually monitor data for signals that indicate potential issues. Once a signal is detected, the alert rule checks if it meets the specified conditions. If the conditions are met, an alert is triggered, initiating the associated action group and updating the alert state. Next, looking at the flow of alerts, Alert rules are separated from alerts and the actions taken when an alert fires. The alert rule captures the target and the criteria for alerting and can be in an enabled or disabled state. Alerts only fire when enabled. We know it's essential to monitor utilization and understand where and how the resources deployed are being used and what they cost the organization. But how do we facilitate this? Diagnostic logging, which is captured at the resource level, is one such tool that will enable you to view detailed logs. Azure Monitor diagnostic logs are logs generated by Azure services that provide frequently collected data regarding their operation and performance. Azure Monitor makes two diagnostic logs available: tenant logs, which come from tenant-level services that exist outside an Azure subscription, and resource logs, which come from Azure services that deploy resources within an Azure subscription. You can enable streaming of diagnostic logs programmatically through the portal or by using the Azure Monitor Representational State Transfer (REST) API. Either way, you must create a diagnostic setting that specifies an Azure Event Hub's namespace and the log categories and metrics you want to send to the namespace. You can create and edit diagnostic settings using multiple methods: Azure Portal, PowerShell, Command Line Interface, or CLI, Azure Resource Manager, Representational State Transfer, REST API, or Azure Policy. In the Azure Portal, you can configure diagnostic settings from the Azure Monitor menu or the Resources menu, depending on the resource type and preference. However, where you configure diagnostic settings in the Azure Portal depends on the resource. Let's summarize. In this video, you learned about the key components of Azure Monitor and its associated tools, emphasizing the importance of monitoring, alerting, and configuring diagnostic settings to ensure the reliability and performance of your Azure resources. Hello, and welcome to the video, Configure Microsoft Defender for Cloud Security Policies. In this video, you'll brush up on your knowledge of implementing Microsoft Defender for Cloud, applying server security baselines, and configuring Defender for Cloud policies and recommendations. Microsoft Defender for Cloud is a cloud-native application protection platform designed to protect cloud-based applications from various cyber threats and vulnerabilities. Microsoft Defender for Cloud facilitates the seamless integration of robust security measures from the start of the software development lifecycle, embracing the concept of development security operations, or DevSecOps. With its multi-cloud coverage capability, you can effortlessly connect to various multi-cloud environments, like Amazon Web Services, or AWS, and Google Cloud Platform, or GCP, for seamless security management. Microsoft Defender for Cloud follows the cyber kill chain approach. While conventional defenses can fend off known intrusions, they lack effectiveness against advanced persistent threats, or APTs. The cyber kill chain, an intrusion detection approach driven by intelligence, has proven effective in identifying and preventing cyber intrusions. The cyber kill chain model consists of 7 phases: reconnaissance, weaponization, delivery, exploitation, installation, command and control, or C2, and actions on objectives. These phases form a cohesive end-to-end process represented as a chain, where disrupting any step can disrupt the entire sequence. Microsoft Defender for Cloud fulfills 3 vital needs as you manage the security of your resources and workloads on premises and in the cloud. First, Microsoft Defender for Cloud Secure Score continually assesses your security posture. Second, Microsoft Defender for Cloud recommendations secure your workloads. And third, Microsoft Defender for Cloud alerts defend your workload in real time. You can customize various global Defender for Cloud settings using the Environment Settings option on the Microsoft Defender for Cloud menu. These settings are established per subscription, which means you have complete control over what's monitored, what data is collected, and where it's stored. You can influence 4 areas: Defender plans, integrations, auto-provisioning, and email notifications. What's more, Microsoft Defender for Cloud fully integrates into Azure Policy. With Azure Policy, you can define specific requirements for your Azure subscriptions, tailoring them to match your workload type or data sensitivity. Microsoft Defender for Cloud also continually monitors policy compliance across your subscriptions using a default set of security policies, such as enabling secure transfer to storage accounts, provisioning an Azure Active Directory, Azure AD, administrator for structured queried language, SQL servers, and utilizing Azure AD for client authentication. Microsoft Defender for Servers, an integral part of the Microsoft Defender suite, offers extended protection for Windows and Linux servers that run on premises and in Azure AWS and GCP. It includes Microsoft Defender for Endpoint, an all-inclusive package that combines endpoint detection and response capabilities for comprehensive server protection. There are 5 stages involved in the successful deployment of Microsoft Defender for Servers. Start protecting resources. Enable Defender for Servers. Protect AWS or GCP machines. Protect on-premises servers. And enable Foundational Cloud Security Posture Management, or CSPM. When it comes to safeguarding your subscriptions, Microsoft Defender for Cloud has you covered. It applies security initiatives consisting of various security policies, each providing recommendations to enhance your security posture. When you set up Microsoft Defender for Cloud, every subscription comes with a default initiative, the Microsoft Cloud Security Benchmark. This benchmark is a comprehensive guide that incorporates top-notch security and compliance best practices from trusted sources. It is designed to prioritize cloud-centric security and keep your systems fortified. Configuring the operating system OS as securely as possible reduces a machine's vulnerability and mitigates known risks. The Microsoft Cloud Security Benchmark has guidelines for OS hardening, which has led to security baseline documents for Windows and Linux servers. Defender for Cloud has 2 recommendations that leverage Azure Policy's guest configuration feature to check if your Windows and Linux machine configurations meet Azure Security Baseline configurations. For Windows machines, vulnerabilities in security configuration on your Windows machines should be remediated, and for Linux machines, vulnerabilities in security configuration on your Linux machines should be remediated. Microsoft Defender for Cloud tailors its security recommendations based on your selected initiatives. That is, if a policy from your initiative detects non-compliant resources during evaluation, it promptly presents them as recommendations within the tool. Each recommendation comprises an issue description, step-by-step remediation instructions, and a list of affected resources. Recommendations help identify the current security state of your created workloads in Azure. Microsoft Defender for Cloud reviews security recommendations across your workloads, uses algorithms to determine the criticality of each recommendation, and calculates a secure score. Secure score is determined by the ratio of healthy resources to the total resources under evaluation. It is the central feature in Microsoft Defender for Cloud that consistently evaluates your cross-cloud resources for security issues. The higher the score, the lower the identified risk level. Here's an interesting fact. When you first access Microsoft Defender for Cloud in the Azure portal or enable it through the API, it becomes free for all your Azure subscriptions and provides instant access to CSPM features. Now let's summarize. In this video, you learned about Microsoft Defender for Cloud, a cloud-native protection platform that secures cloud-based applications. You learned that Defender for Cloud follows the cyber kill chain approach, integrates with Azure Policy, and provides secure score assessment, recommendations, and real-time alert. You also learned that Microsoft Defender for Servers protects Windows and Linux servers. Hello, and welcome to the video Enable Just-in-Time Virtual Machine Access. In this video, you'll revisit concepts related to implementing Just-in-Time Virtual Machine or JIT-VM access, identifying malware threats, and configuring malware detection. Let's get started. A brute force attack is a hacking technique in which an attacker attempts to gain access to a network or system using an automated process to guess the username and password combination. This kind of attack relies on a trial and error approach. Brute force attacks have existed as long as passwords, but they have gained popularity with the increasing shift to remote work. There are various ways attackers can compromise a network or system using brute force techniques. Guessing login credentials using common passwords, using automated tools, using malware kits purchased on the dark web, purchasing data, such as leaked credentials used in credential stuffing or hybrid brute force attacks, or using botnets, systems of hijacked computers that provide processing power without the consent or knowledge of the legitimate user. Brute force login attacks commonly target management ports to gain access to a VM or server. So, can brute force attacks be prevented? Yes. Brute force attacks can be prevented using multiple measures, such as disabling the public IP address, requiring two-factor or multi-factor authentication, limiting login attempts, implementing capture, implementing IT hygiene, setting up policies that reject weak passwords, implementing proactive threat hunting, and limiting the time ports are open. The final approach, limiting the time ports are open, is what Microsoft Defender for Cloud implements on your behalf. Management ports, such as Remote Desktop and Secure Shell, SSH, only need to be open when connected to the VM, that is, to perform management or maintenance tasks. One of the primary methods to enhance cybersecurity is to minimize the attack surface, which means having fewer ports open. Microsoft Defender for Cloud offers a solution called Just-in-Time, or JIT, that supports JIT VM access with advanced security features. Enabling JIT VM access allows Microsoft Defender for Cloud to utilize Network Security Group Rules, or NSG rules, to restrict access to management ports when they aren't in use, preventing potential attackers from targeting them. When you enable JIT VM access for your VMs, you can create a policy that determines the ports to help protect, the duration for which ports should remain open, and the approved IP addresses that are allowed to access these ports. The policy helps you control what users can do when they request access. To enable JIT VM access, you must first enable Microsoft Defender for Cloud. Then, select a VM that does not have JIT VM access enabled. Under the Settings blade of the desired VM, select Configuration, and then select Enable Just-in-Time. After JIT VM access is enabled for the desired VM, select Open Microsoft Defender for Cloud. On the Just-in-Time VM access page, select the checkbox beside the desired VM. Then, select Request Access. On the Request Access page, select the ports you would like to open per VM using the toggle switch. Select Open Ports to finalize the JIT network access request. To change a port, if required, select the ellipsis corresponding to the VM. Then select Edit. On the JIT VM access configuration page, select Add to add a new port. On the Add Port Configuration wizard, enter the desired port and select OK. Then select Save to add the new port. Alternatively, you could enable JIT VM access in Microsoft Defender for Cloud on the Not Configured tab of the Just-in-Time VM access page. Next, let's understand malware threats. Hackers often access systems by impersonating a real user or inserting malware into a computer or device with authorized network access. So, what's malware? Malware refers to software specifically designed to cause harm to a computer or network. One of the common ways malware infiltrates systems and networks is by exploiting vulnerabilities in the software or tricking unsuspecting users into unknowingly installing it. Some common forms of malware include viruses, worms, and Trojan horses. However, the good news is that you can protect your systems and networks from malware threats by keeping your servers up to date, installing anti-malware, using firewalls to block network traffic, and integrating your anti-malware solution with Microsoft Defender for Cloud. Microsoft Defender for Cloud plays a crucial role in monitoring the anti-malware protection status of your VMs. It actively detects issues that could potentially render your VMs and computers susceptible to malware threats. You can then address any identified problems using the information on endpoint protection issues. Microsoft Anti-Malware for Azure is available as an extension you can add to existing VMs or include while creating a new VM. You have various options to add the extension, such as using the Azure Portal, the Azure Command Line Interface, CLI, PowerShell, or the Azure Resource Manager template. Let's wrap up. In this video, You learned about enabling JIT VM access and addressing cybersecurity concerns, including mitigating brute force attacks and protecting systems and networks from malware. You learned that Microsoft Defender for Cloud plays a crucial role in monitoring VM's anti-malware protection status and actively detecting issues for improved security. Finally, you learned that Microsoft Anti-Malware for Azure is an extension you can add to existing VMs or include while creating a new VM. Hello, and welcome to the video, Create Custom Analytics Rules in Microsoft Sentinel. In this video, you'll refresh your knowledge of adding Microsoft Sentinel to workspaces, creating custom analytics rules to detect threats, and using playbooks with automation rules. Let's dive right in. Microsoft Sentinel is a scalable cloud-native SIEM and SOAR solution, where SIEM stands for Security Information and Event Management, and SOAR stands for Security Orchestration, Automation, and Response. Microsoft Sentinel integrates with various Microsoft 365 solutions and other Microsoft security products, such as Azure Identity Protection, Microsoft Cloud App Security, Microsoft Defender for Identity, Microsoft Intune, and Azure Information Protection, or AIP. Microsoft Sentinel offers a range of capabilities. It collects data at cloud scale, detects previously undetected threats, investigates threats with artificial intelligence, and responds to incidents rapidly. Microsoft Sentinel provides robust features and components that contribute to its comprehensive security monitoring and response capabilities. They include data connectors, log retention, workbooks, analytics alerts, threat hunting, incident investigation, and automation playbooks. In addition, Microsoft Sentinel offers a workspace environment where security analysts can analyze the data collected. To create a workspace, navigate to Microsoft Sentinel. On the Microsoft Sentinel page, select Create. Next, on the Add Microsoft Sentinel to a Workspace page, select Create a new workspace. On the Create Log Analytics Workspace page, on the Basics tab, enter all the required information and select Review plus Create. Then, on the Review plus Create tab, select Create. Alternatively, to add an existing workspace, on the Add Microsoft Sentinel to a Workspace page, select the desired workspace and then select Add. A content hub is a centralized location to discover and manage unique content, such as data connectors. Installing solutions from the Content Hub enhances Microsoft Sentinel's capabilities. To set up Microsoft Sentinel in Azure, you must first connect with security sources and configure data connectors. Microsoft Sentinel provides numerous connectors specifically designed for Microsoft solutions. In addition, Microsoft Sentinel has various data connection techniques: service-to-service integration, external solutions via APIs, and external solutions via agents. Moving on, ingestion time data transformation gives you control over the data ingested into Microsoft Sentinel. It allows you to filter and enrich output tables, even before running any queries on the data. Ingestion time data transformation uses data collection rules, or DCRs, to collect and manipulate data before storing it in the workspace. Let's understand the data ingestion flow in Microsoft Sentinel. Microsoft Sentinel first collects data from multiple sources and stores it in the Log Analytics workspace. The data from built-in data connectors is processed in Log Analytics using a combination of hard-coded workflows and ingestion time transformations in the workspace DCR. This data can be stored in standard tables. The data ingested directly into the Logs Ingestion API endpoint is processed via a standard DCR, which may include an ingestion time transformation. This data can then be stored in standard or custom tables. Microsoft Sentinel offers workbooks that provide comprehensive access to Azure tools, enabling you to perform detailed analytics on your logs and queries. Microsoft Sentinel utilizes the Kusto Query Language, or KQL, for interactive analytics, enabling you to visualize and examine the collected data effectively. Once you connect your sources to Microsoft Sentinel, you can monitor your data through seamless integration with Azure Monitor Workbooks. Microsoft Sentinel Workbooks enable you to create interactive reports by combining texts, analytics queries, Azure metrics, and parameters. You have two options when working with Microsoft Sentinel Workbooks. You can use an existing workbook as a base or create a new workbook. Microsoft Sentinel also provides customizable anomaly detection analytics rules. These rules come with built-in templates that can be easily modified within the user interface. You can find anomalies on the Anomalies tab of the Analytics page. You can then query and assess them using the Anomalies Analytics Rule ID on the Logs page. Next, let's recap creating incidents in Microsoft Sentinel. Alerts from connected Microsoft security solutions are stored in Sentinel's Security Alert table. While most solutions can automatically create incidents, some, such as Microsoft Defender for Cloud Apps and Microsoft Defender for Identity, require additional configuration. Microsoft security incidents use analytics rules for incident creation in such cases. Analytics rules scan your environment for specific events or patterns, triggering alerts when certain event thresholds or conditions are detected. They also automatically create incidents for your Security Operations Center, SOC. To create a custom analytics rule with a scheduled query, select an existing Sentinel. Then select Analytics. On the Analytics page, select Create, and from the drop-down list, select Scheduled Query Rule. On the Analytics Rule Wizard page, on the General tab, enter the required details and select Next, Set Rule Logic. On the Set Rule Logic tab, create the desired query in the Rule Query box and wait till the system evaluates your query. Alternatively, select View Query Results. In the Logs page that appears, create the desired query. Then, copy that query and paste it into the Rule Query box on the Set Rule Logic tab. Next, in the Alert Enhancement section, under Entity Mapping, select Add New Entity to add a new entity. Entity mapping is an integral part of configuring scheduled query analytics rules. You'll be able to investigate an incident using the investigation graph only if you've added entities during the setup of your analytics rule. Then, select Next, Incident Settings. Finally, on the Review and Create tab, select Save. Let's explore the key features of Microsoft Sentinel that enhance security operations and threat detection. Playbooks, a collection of remediation actions that can be executed within Microsoft Sentinel, helps automate and orchestrate threat responses. Playbooks can be triggered manually on specific entities or automatically in response to alerts or incidents triggered by an automation rule. They can be combined with automation rules to automate incident response and remediate security threats detected by Microsoft Sentinel. Microsoft Sentinel's auditing and health monitoring feature lets you monitor the activity of key service resources and inspect user action logs within the service. Watch lists in Microsoft Sentinel allow you to correlate data from a data source you provide with the events in your Microsoft Sentinel environment. Moving on to the last feature, you can monitor the health of your data connectors using the Health Monitoring Workbook and the Sentinel Health Data Table. Let's wrap up. In this video, you learned that Microsoft Sentinel is a scalable, cloud-native SIEM and SOAR solution. You also learned how Microsoft Sentinel integrates with various Microsoft solutions and offers various functionalities. Overall, you learned how Microsoft Sentinel equips organizations with robust security monitoring and response capabilities, optimizing threat detection and incident management. Hello, and welcome to the video, Investigate Incidents and Threats with Microsoft Sentinel. In this video, you'll recap how to hunt and investigate suspected breaches, investigate an incident with Microsoft Sentinel, and use the Search Job feature. You'll also refresh your knowledge of the threat modeling phases and the threat modeling tool. Let's begin. Most attacks follow a common process that's referred to as the kill chain. This process follows a basic pattern involving a step-by-step progression that guides the attack towards its desired outcomes. Organizations can counter such attacks by implementing security measures at key choke points within the chain. However, as attackers can employ various exploitation techniques to bypass any step, robust defense strategies must be applied at every stage of the chain. To hunt and investigate potential breaches in the cloud and Microsoft Sentinel environments, enable Microsoft Defender for Cloud, monitor security alerts, investigate alerts, use advanced analytics, collect and analyze logs, implement network security best practices, perform regular vulnerability assessments, implement access controls, develop an incident response plan, and finally, stay updated with the best practices and updates from Microsoft. Once you've connected your data sources to Microsoft Sentinel, your primary goal is to receive notifications regarding suspicious activities. Microsoft Sentinel enables you to accomplish this by providing the capability to create custom analytics rules that generate incidents that you can assign and investigate. An incident is an aggregation of all the relevant evidence for a specific investigation and can include multiple alerts. An incident is created based on the analytics rules you create on the analytics page. There are two prerequisites to consider before you investigate incidents in Microsoft Sentinel. 1. You'll be able to investigate an incident only if you've added entities during the setup of your analytics rule, as the investigation graph requires that your original incident includes entities. 2. If you have a guest user who needs to be able to assign incidents, the user must be assigned the directory reader role in your Azure AD tenant. To investigate an incident with Microsoft Sentinel, on the desired Microsoft Sentinel page, under Threat Management, select Incidents. The Incidents page provides an overview of all the incidents. To initiate an investigation, select a specific incident. On the right-hand side of the Microsoft Sentinel Incidents page, scroll down and select View Full Details. You can then review the 6 tabs that summarize information on the desired incident and take necessary action. Timeline, Similar Incidents Preview, Alerts, Bookmarks, Entities, and Comments. The investigation graph empowers you to ask the right questions for each investigation. By correlating relevant data with the associated entities, the investigation graph helps you understand the scope and identify the root cause of a potential security threat. To use the investigation graph, first select an incident. Next, on the left pane of the incident page, select Investigate. This action will take you to the investigation graph, which provides an illustrative map of the entities directly connected to the alert and the resources connected further. You can further expand your investigation by hovering over each entity. You can also view all the entities in the raw logs and corresponding queries used in Log Analytics for each exploration query. The investigation graph also provides a parallel timeline feature to understand the incident better. Microsoft Sentinel provides a search job feature that allows you to search archived logs across long periods and large datasets. To access this feature, in Microsoft Sentinel, under General, select Search. Next, on the search page, enter a search name in the search box and select Start to view the advanced KQL editor and preview the results for a specified range. To view the searched results, on the search page, select the Saved Searches tab. Next, select a search card and select View Search Results Preview. On the Search Results Preview page, view all the results that match your original search criteria. Let's recall what you learned about threat modeling, its phases, and the threat modeling tool. Threat modeling is an effective technique for securing your systems, applications, networks, and services. This technique helps identify potential threats earlier in the development lifecycle and formulates risk mitigation strategies. Threat modeling has 4 phases: design, break, fix, and verify. The Threat Modeling Tool is a core element of the Microsoft Security Development Lifecycle, SDL. It involves creating a diagram, identifying threats, mitigating them, and validating each mitigation. The threat modeling tool allows users to specify trust boundaries to show where different entities are in control. For example, IT administrators require an Active Directory system for authentication purposes, so the Active Directory is outside their control. It's time to summarize. In this video, you learned the benefits of using Microsoft Sentinel for hunting and investigating incidents, utilizing the search job feature, and implementing the threat modeling tool. These approaches help organizations strengthen their cybersecurity capabilities, minimize the risk of security breaches, and enhance their resilience against cyber threats. Great job! You've gone through the recap of the key concepts covered in the 6 courses of the Microsoft Azure Security Engineer Associate Professional Certificate Training Program. As a Microsoft Security Engineer, your core duties will encompass securing access, identity protection, platform protection, application and data security, network security, and managing security operations. You're now aware that these tasks play a crucial role within your organization's defense in-depth strategy. Defense in-depth involves implementing multiple layers of security measures to protect organizational resources and digital assets against various threats. This illustration depicts an example of multiple-layer security in the case of a cyber threat, where you first lock down the perimeter and then work your way inward, locking down each layer. Defense in-depth is the underlying security approach that secures your identity, platforms, applications, data, networks, and operations. Let's summarize what you learned regarding the various layers of protection in the defense in-depth strategy. You learned that Azure Active Directory, or Azure AD, which is a part of Microsoft Intra, is a comprehensive identity and access management solution. Azure AD is important for organizations aiming to streamline user management and authentication across their cloud services and applications. You learned about the identity protection aspect of defense in depth, which involves activities related to managing users and groups in Azure AD, assigning and removing licenses, implementing various authentication methods, managing passwords effectively, and utilizing multifactor and passwordless authentication to ensure secure access to resources and systems. Delving into the access control and resource protection aspects of the defense in-depth approach, you learned that Azure AD Identity Protection is designed to protect your identities through a 3-part process: detect, investigate, and remediate. You then brushed up on the various aspects of identity protection, access control, and resource management within Azure. You also explored risk-based policies, multi-factor authentication, conditional access policies, access reviews, and the methods of investigating and remediating risks. Additionally, you reviewed Azure Role-Based Access Control, RBAC, including built-in roles, custom roles, and the differences between RBAC and Azure Policy. You also revisited resource management using resource locks, resource groups, Azure Blueprints, subscriptions, and management plans. Progressing further, you reviewed perimeter security, an essential aspect of the defense in-depth strategy. Perimeter networks, also known as demilitarized zones or DMZs, help provide secure connectivity between cloud networks, on-premises or physical data center networks, and the Internet. You also learned about Azure Firewall, a managed cloud-based network security service that protects your Azure Virtual Network resources. You learned how network security plays a crucial role in the defense in-depth strategy. Network security groups, or NSGs, can be used in the Resource Manager deployment and the classic deployment model for fortifying security. NSGs manage inbound and outbound traffic through network adapters or virtual machines, VMs, within a subnet. You then revisited concepts related to application security in Azure, which covered encrypting, configuring, and implementing application gateways, deploying Web App Firewall, WAF, configuring Azure Front Door, and reviewing Express Route. You also learned about configuring and managing host and container security. You then brushed up your knowledge of the configuration management and deployment of Azure Kubernetes Service, or AKS, a portable and extensible open-source platform for managing and orchestrating containerized workloads. You refreshed your knowledge of how Azure Key Vault uses vaults, keys, and secrets to enhance the security of your applications and data. You also explored how to secure applications in the Microsoft Identity Platform. An evolution of Azure AD, the Microsoft Identity Platform implements the OAuth 2.0 authorization protocol. It allows you to build applications that sign in users and access resources and external Microsoft applications, other software as a service applications, or SaaS applications, and internal resources. You then revisited Microsoft Graph, which provides data access across Microsoft 365 services, ensuring an integrated experience for users. Progressing further, aligning with the data protection and access control aspects of the Defense in-Depth strategy, you reviewed implementing access control mechanisms to secure Azure Storage. You went through data sovereignty, shared keys, shared access signature, and access policies. You refreshed your knowledge about authenticating access to a storage account, securing data at rest, securing data in transit, and controlling how data is accessed and transmitted. You then revisited safeguarding Azure SQL database with insights into authentication, firewalls, and virtual network or VNet service endpoints. You explored Microsoft Defender for Cloud, emphasizing cloud application security, posture improvement, and workload protection. You also reviewed the importance of encryption, data masking, and features like always encrypted for securing data. Aligning with the monitoring and incident response aspect of the Defense in Depth strategy, you revisited monitoring, detecting, and responding to potential security incidents and threats. You explored the key components and tools for reliability and performance in Azure Monitor. You also refreshed your knowledge on how Microsoft Defender for Cloud secures cloud apps, follows the cyber kill chain approach, integrates with Azure policy, and provides secure score assessment. Finally, you reviewed how Defender for Servers protects Windows and Linux servers, enabling just-in-time virtual machine or JIT-VM access, mitigating attacks, and monitoring anti-malware. You also learned how Microsoft Sentinel integrates with Microsoft Threat Detection and Response tools. That was an incredible journey. We hope you found it enriching. You're now fully prepared to confidently tackle the module quiz, which will comprise questions from all 6 courses in this program. The module quiz will be followed by the practice exam, which is designed to mimic the AZ-500 exam. Finally, you'll be all set to attempt the AZ-500 exam. Here's to continued success.
Hello, and welcome to the video about the course project. In this video, you'll get an overview of how the project is structured. You'll also understand the tasks you'll perform and the deliverable you'll create during this project. This is the final capstone project for the Microsoft Azure Security Engineer Associate Professional Certificate Training Program. In this project, you will apply the knowledge and skills acquired across all 7 courses to a real-life scenario. The tasks in this hands-on project correspond to the key activities performed by Azure security engineers and administrators as part of their organizational responsibilities. We'll provide you with a detailed project scenario. Imagine yourself as an Azure security engineer at a retail company called Buy for Sure. As part of the company's Defense in Depth strategy, you'll implement multiple layers of security. You'll perform tasks related to authentication, securing storage, encryption and monitoring, and threat detection. When you complete this project, in addition to the hands-on experience, you'll have a simulated project implementation to use as a work sample during interviews. You'll create one deliverable for this project, the Azure Security Project Solution document. You can create this document using Microsoft Word or any other similar application. The activities in this project will focus on safeguarding the intellectual property of Buy for Sure. You will protect a confidential design image that the company will use for marketing. You'll apply multiple layers of security to ensure that only authorized personnel can access the image and that it's protected from malicious attacks. Now, let's look at the tasks you'll perform. Based on the scenario, you'll create users in Azure Active Directory. You'll then create a group with these users. You'll enable multifactor authentication for all the members of the group. Then you'll upload the confidential image to a container in a storage account. You'll implement role-based access control, also called RBAC, for the storage account. You'll create a virtual machine for the sales team to access the image. You'll also ensure that users can access the file only through a shared access signature URL. In addition, you'll secure the storage account by encrypting the storage account and utilizing Azure Key Vault and a customer-managed key. That's not all. You'll implement Microsoft Defender for the storage account to stay vigilant for malicious content uploads and unauthorized access. Moreover, you'll configure diagnostic settings to send data to the log analytics workspace for tracking user transactions. While performing the project tasks, you'll document screenshots as evidence of what you implemented to secure the confidential design image. This document will form your deliverable, the Azure Security Project Solution document. To give you a head start, we'll provide you with a template called Azure Security Project Solution Template. You'll also be provided with detailed instructions to help you successfully move from one task to another and create the deliverable. These instructions will help you create a deliverable containing all the information required for evaluation. Although there's no time limit for finishing this project, considering your Azure experience, it might take you 1.5 to 2.5 hours to complete all the tasks. Setting aside this time and completing all the tasks in one session is good because the tasks are closely connected. What are the next steps? After submitting your deliverable for peer review, you'll be required to review the submission of 2 peers. You'll review these submissions using the rubric provided and provide feedback. You will, in turn, receive feedback on your submission from a peer reviewer. We'll provide instructions on participating in the peer review process and using the rubric for evaluating your peers' deliverables. After you complete the peer reviews, you can download an exemplar listing all the steps and screenshots for completing the tasks. You're encouraged to compare your submission with the exemplar, which will provide insight into how Azure security engineers usually perform these tasks. You can then participate in an optional discussion with your peers and reflect on the key takeaways from your final project submission. Let's summarize. Here are the key points to remember. While completing the course project, read and follow the instructions carefully. Use the template and information provided to complete and submit the project deliverable. Then complete your peer reviews, compare your submission with the exemplar, and discuss the key takeaways with your peers. Let's get started. Hello, and welcome to the video, Project Scenario. In this video, you'll gain insights into Buy4Sure's company profile, specific requirements, and key priorities. You'll use this information to implement security measures for Buy4Sure in Azure as part of the final Capstone project. The Capstone project will allow you to apply your knowledge and skills in a real-life environment. Let's discuss the project scenario. Buy4Sure is a multinational retail organization with over 250,000 products and assortments. The company has retail and e-commerce stores with sales and support organizations across geographies. Buy4Sure has its headquarters in Texas, North America. The headquarters has 50,000 employees. The headquarters is linked to regional hub offices that serve a specific region of the world with sales and support staff. The regional hubs have an average of 25,000 employees. Each regional hub is linked to several satellite offices that house 80% of the sales and support staff. They provide an on-site presence for Buy4Sure customers in key cities or subregions. The satellite offices have an average of 2,500 employees. The company owns a large amount of high-value intellectual property in the form of design specifications of products and trade secrets. The company is revamping its approach to face the tough competitive market. As part of a strategy to increase its customer base, it is launching a new jewelry brand and introducing exclusive designs. It has assembled a sales team with 3 new employees to promote its jewelry brand. This team needs access to some of the pre-release marketing material of this jewelry brand. The company recognizes how critical it is to safeguard the pre-release marketing material, including design images, from competitors. A leak could lead to the brand's failure in the market. Buy4Sure uses Azure Cloud Services. The company wants you, their lead security engineer, to use the security features in Azure to safeguard brand-related assets. Let's look at some of the Azure features and services that Buy4Sure uses. Buy4Sure uses Azure Active Directory, also called Azure AD, to manage user identities. Using Azure AD ensures that only authorized personnel can access sensitive information. The company enforces multifactor authentication for its employees to add an extra layer of security during login attempts, reducing the risk of unauthorized access. Additionally, Buy4Sure utilizes Azure Storage accounts to store valuable data, including design specifications and trade secrets. Data is organized within containers for efficient management. The company employs Azure Key Vault to manage keys, secrets, and certificates securely. Azure Key Vault centralizes key management and provides additional protection for critical assets. Buy4Sure uses Microsoft Defender for Cloud to enhance the security posture of its cloud resources. This technology helps the company identify and mitigate potential threats in real time. You are assigned the task of safeguarding company assets using the security features available in Azure. You must ensure that the pre-release marketing material is not accessed by any unauthorized person or leaked to competitors before the official launch. In this course project, you'll focus on safeguarding a confidential design image while providing the required access to the 3 sales team members. Wish you the very best as you implement the security measures in Azure.
Exams are excellent opportunities to demonstrate your knowledge. Engaging in practice exams is like a dress rehearsal for the main exam, where you can strengthen your learning, learn from mistakes, and enhance your time management. Hello, and welcome to the video Introduction to the AZ-500 and Practice Exams. In this video, you will get a quick overview of the AZ-500 Microsoft Azure Security Technologies exam. You will also understand the details of the practice exam you will complete as part of this week's learning. Keep in mind that Microsoft updates the exam and certification information regularly. This video is based on the skills evaluated in the AZ-500 exam as of August 23, 2023. The AZ-500 exam is aimed at those who implement, manage, and monitor security for resources in Azure, multi-cloud, and hybrid environments as part of an end-to-end infrastructure. When you successfully complete the AZ-500 exam, you will earn the Microsoft Certified Azure Security Engineer Associate certification. Let's look at the 4 skills areas tested in the AZ-500 exam. The first area is Manage Identity and Access. You can expect 25 to 30% of exam questions from this area. This skill area will cover questions about using Azure Active Directory, also called Azure AD, to manage identities. The questions will also focus on utilizing Azure AD to manage authentication, authorization, and application access. The second area is secure networking. You can expect 20 to 25% of exam questions from this area. This area will have questions about planning and implementing security for virtual networks, private access to Azure resources, and public access to Azure resources. The third area is secure compute, storage, and databases. About 20 to 25% of exam questions will be from this area. You can expect questions related to planning and implementing advanced security for compute, storage, Azure SQL database, and Azure SQL managed instance. The last skill area is manage security operations. You can expect 25 to 30% of exam questions from this area. The questions will be based on planning, implementing, and managing governance for security and managing security posture using Microsoft Defender for Cloud. The questions will also cover configuring and managing threat protection using Microsoft Defender for Cloud and configuring and managing security monitoring and automation solutions. The AZ-500 exam consists of 40 to 60 multiple choice questions. The questions can be screenshot based or case study based. Some questions may present scenarios with multiple correct options, requiring you to choose the most suitable answer. You might get about 100 minutes to answer the questions. How are scores determined for this exam? The scores are reported on a scale of 1 to 1000. You should have a minimum score of 700 to pass this exam. For multi-part questions, you will receive 1 point for each correctly answered component. You can earn all, some, or none of the points possible for that question. No points are deducted for incorrect answers. You'll have the results within minutes of finishing the exam. You'll also get a report with your exam score and feedback on your performance. You can take your exam online or at one of the Microsoft test centers. Now that you have gone through some of the details of the AZ-500 exam, let's look at the practice exam you will attempt this week. The practice exam mimics the AZ-500 exam and evaluates your knowledge and understanding of the 4 skill areas. As you prepare for the practice exam, remember that you can still revisit and reinforce the main concepts. The practice exam lasts 2 hours. You can expect 40 questions. Similar to the AZ-500 exam, the practice exam is timed. After 2 hours, the test will automatically end. A timer is displayed during the exam to show the remaining time. The practice exam allows you to navigate back and forth between questions and modify your answers before the final submission. Each question in the practice exam carries a value of 1 point with a maximum of 40 points that you can earn. It is important to note that there is no negative mark for incorrect answers. You should achieve a minimum score of 80% to pass this practice exam. Take time to carefully read each question before selecting your response. To prepare effectively for the AZ-500 certification exam, we recommend creating a similar environment for the practice exam. This entails finding a quiet space to take the exam and closing all other applications and browser pages to simulate the exam environment. Good luck with the practice exam. Congratulations! You have completed the course Capstone and Practice Exam. This was the 7th and the last course in the Microsoft Azure Security Engineer Associate Professional Certificate Training Program. This course is part of the preparation for the AZ-500 Microsoft Azure Security Technologies exam. In the first week of this course, you reviewed the main concepts discussed in the preceding 6 courses of the training program. These courses are Secure Access with Azure Active Directory, Identity Protection and Governance, Implement Platform Protection, Secure Your Applications, Secure Your Data at Rest, and Manage Security Operations. In the second week, you completed a Capstone project. This Capstone project covered the defense-in-depth aspects of an important Azure service, the Azure Storage account. You performed activities related to authentication, encryption, secure storage, threat detection, and monitoring. In the third week, you prepared for the practice exam by refreshing your knowledge about the AZ-500 exam and reviewing the study guide. You completed the practice exam this week with questions from all 4 skill areas tested in the AZ-500 exam. The skill areas are Manage Identity and Access, Secure Networking, Secure Compute, Storage, and Databases, and Manage Security Operations. The Microsoft Azure Security Engineer Associate Professional Certificate Training Program has aimed to prepare you for the AZ-500 exam. Successfully finishing the content across all 7 courses, passing the assessments, and completing the hands-on projects should give you a significant advantage when taking the exam. Do refer to the content provided in this program during your continued preparation for the AZ-500 exam. Remember to refer to the Microsoft website for the latest updates on the exam. Before you wrap up this course, you have 2 more things to explore. First, you can review the enrollment information that would help you enroll for the AZ-500 exam. You will also get an opportunity for a peer discussion. You can use the space to ask questions or share thoughts about what you learned in the course or how the exam works. Best of luck with your exam preparations and for the final exam.